Good morning, guys. Good morning, guys. Thank you guys for coming and welcome to DappCon 2026. We've been doing this on a mostly yearly basis since 2018. We've missed a couple of years due to COVID. So we've seen a lot of these cycles, so they don't worry us so much anymore. The one thing that does worry me to some extent is if you look at the past year, it's been absolutely relentless for hacks, right? Every other week, we've seen a major exploit somewhere or other. It's been a complete battering for the ecosystem. A lot of these hacks, most of these hacks, presumably, have been AI assisted, right? So that begs the question, what do we do about this? When you used to have a team to conduct an exploit, now you need Claude code and a couple of tokens. Otherwise, it's become much easier to find and exploit vulnerabilities. So while I think all of us use AI daily, and it's leveled us up in terms of productivity by a factor of 5 to 10, we also have to deal with this flip side. So how do we deal with it? And I would argue that the best way to deal with it primarily is to reduce complexity. So the question must always be, what is the smallest set of things I will position? Things that we build should be simple enough to reason about. And if you think about it, resilience ends up being mostly subtraction rather than addition. And this is more important now than ever, because if you think about AI is a hugely centralizing force, right? So it relies on enormous compute, on capital, on data, and there's a handful of companies that supply this to us. So intelligence, in effect, is becoming a utility that you rent from a landlord, and there's not a lot of landlords. So this, in some respect, is the deepest platform risk we've ever faced. So we used to spend years worrying about, but who owns the app? Who owns the app? And now, really, what we should be worrying about is who owns the reasoning, right? So I would posit that we need Web3 more than ever to counter the centralizing force with the decentralizing force that we can have in this ecosystem, where we can give back people ownership and control over their own digital lives. So please listen to all the talks and go forth and build things that hold. Welcome to DappCon 2026.
Okay. To kickstart the day, please give a warm welcome to Paul Lenski, CEO at DappNode, speaking on AI beyond Claude and GPT. How to use AI and not kill privacy trying.
Thank you. Good morning, everybody. Welcome to Berlin. I was telling Armand that I always talk last at the presentation or the last days, and it's such a pain in the ass because you're the whole conference. You're thinking, how's it going to be? Am I going to do it properly? So I'm going to do it terribly now, and then I can be relaxed. I can relax, or I can beat myself up for doing it so poorly for the rest of the conference. Right. So AI private. Why do we need private AI? In the 1st of January, 2025, it was New Year's Eve. It was after midnight. Everybody was celebrating. Everybody was happy. And in a trailhead in California, there was a man. He was wearing a cap. He was smoking a cigarette. He had arrived there with his car. He came with a mission, and he did what he needed to do. And 7 days after, a massive fire was raging through the Palisades in California. It burned 23,000 acres, destroyed more than 6,000 buildings, and killed 12 people. The guy that did it asked ChatGPT to generate these images right before it happened. And he called 911 to report the fire. And while he was doing it, because we have the time data, while he was on the phone, waiting on the phone, he asked ChatGPT, am I liable for if I cause a fire with a cigarette? Can I pretend that the cigarette just fell? So they caught him. He's facing 30, 40 years in prison. And they caught him because one of the reasons is because he used ChatGPT. They used many other things. They used cell phone tower data. He was the only person in the area. But OpenAI willingly provided these documents and saying, hey, that's how we have access to this picture. This is his private history with OpenAI. He generated these pictures. Luckily, the picture quality on ChatGPT has improved a lot. There are only two ways of getting private inference. You either run it locally, or you get a confidential compute API. You can run it locally in your hardware, then it doesn't leave. And if you run it in somebody else's computer, you need some verifiable assurance that they are not keeping this. Because if you cannot verify it, it's basically as if they're using this data, right? Okay, why do we even need private AI? I think the fire example might be a good example. But you're thinking, hey, I'm not a criminal. I'm not using ChatGPT to ask for how to commit crimes. But you might be asking, but I like to think about why do we need privacy in AI in terms of inputs and in terms of outputs. What you give the AI and what the AI gives you. Basically, some information must remain confidential. The AI is a black hole of data. It will suck all of the data up. And if you have private code, you have client data, you have health records, if you send it to a model, it means that you have lost it. You have no privacy guarantees. Anybody can use it. If you regulate it, the rules have already decided for you. You cannot share with OpenAI certain data about your customers. If you're not regulated, well, all the data that you give up, it can be used and it's not yours anymore. And in a time where you can just point an AI to a product, to a website, and say, make a clone of this. The only thing that makes you different is the data that you use to make that product better. And then are people worried that AI is going to take their jobs? Well, you've been telling the AI exactly how to do your job since ChatGPT started. How do you want it not to take your job? There's one example that we were talking with Sebastian right here yesterday, and we were talking about blood results, for example. And I was thinking blood results or like health data, personally, touches us all, right? And you can share this with ChatGPT and say, hey, what does this blood panel say? Am I okay? And it will give you a really good answer. But the next year, when you go to renew your private insurance, for those who are lucky to have private insurance, you might find your premium has increased. And you're like, hey, how is my premium increased 40%? Oh, because you're in a risk population group. How do you know I'm a risk population group? Well, because your cholesterol is that much. How the fuck did you know my cholesterol? You just gave it away. You gave it to ChatGPT. So do you know this movie? This movie is Minority Report. They predict the future with all the data that they have. And we're going to a world where you can say, hey, how can I start a forest fire? And there is some Minority Report style type that they caught this guy. You can say, hey, what does this blood result, this blood test result means? And there is a world where insurances have access to this data. And if you're in a country that is autocratic and you want to do something against the government, you can say, hey, how can I rebel against this dictator? And the dictator will detain you before you can even start doing something. How can I organize a demonstration against the government? And you can be detained even before the demonstration starts. You're giving this data away. All right, so this is in terms of inputs. What do you give to AI? But in terms of outputs, LLMs act as our brain, and they give us superpowers. This is all of these agents that we spawn, all of these brains. They do amazing stuff for us, and not using them kind of puts us behind. You're a lot more productive if you use one of these, right? But how do you know that they are acting properly? If it is your brain, and you don't control this brain, you basically have a brain parasite. It's doing whatever it wants to do, but it doesn't work for you. It works for another company. It works for this alien. It works for a company that does not have your best interests at heart. You pay $20 a month for your ChatGPT subscription. I'm sorry, but you're not making bank for them. They are not working for you. There is the open source models as well. Open source models, this is a Qwen 3.6, 30 billion, I think. And if you asked what happens in Tiananmen Square, sorry about the typo there, if you ask what happens, it will not respond to you. It'll not say certain things. There's some parts of the brain that you can literally not use. This does not exist. They're rewriting history. Fable from Anthropic is used to code, and everybody used it, and it was fantastic. But if you asked it how to do LLM research, frontier LLM research, it would cap the results. It would deteriorate the response on purpose, so you cannot use it to compete against Anthropic, because Anthropic is a private company, and they're not going to give you the tools to compete with them. So Andrej Karpathy has this thing, not your keys, not your crypto, that's what we say in the crypto world, but then not your weights, not your brain. If you don't know what's in that brain, it's not your brain. So basically, this is it. This is us. This is you, looking at the shadows, looking at the response, looking at the inference. And these are the models that will basically give you this truth. It's like Plato's cave. This is not the truth. You take it as the truth, but it is lobotomized. It can be degraded. The results can be poisoned, or it can just change halfway. They change a flag server side, and it just changes the behavior. They can just cut the access like they do with Fable. So basically, I like to think about it in this way. What happens to your data? Well, your data in a public API is logged, and if you use a verifiable inference provider, it is encrypted, and you can verify that it's only accessible to you, even though the computation, the inference happens somewhere else. And if you run it locally, then of course, it never leaves your machine. You have the strongest guarantees. Who controls the weights? Well, if the model lives somewhere else and is not open source, they. If you run it in a confidential TE, you choose. And if you run it locally, well, you choose as well. Where does the inference run? Their servers. In a TEE, it's still their servers, but at least you have these verifiable guarantees. Or again, if it runs in your hardware, this is it. And here's the trade-off that we need to talk about, right? State-of-the-art models. Everybody wants to use Fable. It's the most intelligent one. It's the best of the best. But how bad are open source models? They're 4 to 6 months behind the state-of-the-art. And here's why local, this is also the reason why local is also not the best option. Because you can usually need a lot of hardware, very, very expensive hardware. It's not cost efficient for you to have this huge model. So you can run local, but it's going to have to be smaller models. Let's see how behind those models are. And you can see here the open source models are in pink, and the closed source models are in green teal color. So you can see that it's 4 to 6 months behind on intelligence. It's not that bad. It's actually very good. And it's extremely good if you consider the next slide, which is the cost. The cost is incredible. DeepSeek V4 Pro with max syncing, it gets you a 0.06 cents per agentic task, whereas Fable can go up to 3.25. So you're going to spend a lot of money if you're using Fable, and if you use something that is just 4 months behind for most of the stuff that you can do, it's so much better to do it like this. All right, so where do you land? You have regulated, you're regulated in your industry, you have client or health data that you really absolutely cannot let go. Run it local, run it in your own hardware. It does not leave your premises, it does not leave your hardware. That's the way to go. You need agentic use, you need things where speed matters a lot, and cost efficiency as well. You can still get really, really, really good assurances with verifiable TEE inference if you run it in a confidential API. But you need to demand that you can test this. There are products out there that say private inference, but it works on a trust me bro model. Like, you have to trust them. You have to trust them that, like, how do I know that you're not keeping these logs? And they cannot provide assurances. You have to make sure that whatever you use, they provide assurances that this data is verifiably does never leave the TEE. And then if you have something low stakes, or you want to do a quick prompt or a quick question, then public API is fine, of course. All right, so we're back here. We're back to running it locally, owning your own hardware. It never leaves. Or you can use confidential compute API. So, as you know, many of you already know DappNode, and we have been helping people run complex things. We help people run Gnosis chain validators, Ethereum validators, with a couple of clicks. Very, very easy, very nice UI. You have a Dapp store. You just click here, and you download whatever you want. We're doing the same with local models, local inference. And here, I would like to separate where the inference happens and where the agent happens, right? Because the agent can run locally, but the brain requires a lot more. The brain is the LLM, requires a lot more computation, right? So you can run both. The piece of hardware that you can see here is a DGX Spark from NVIDIA. You can run pretty good models in there, pretty good models, and fairly fast. It's not state-of-the-art models, but if you combine a couple of them, you get very close to state-of-the-art. But the agents that decide, you can run them on DappNode, and any DappNode. It doesn't have to be a DGX Spark. In your 3-year-old DappNode that you might have, you can still run those agents. But then we're missing, where's the computation happen if I have a 3-year-old DappNode? The computation needs to happen in an API. Oh, sorry. So in the DappNode, we've added a chat. We've added an MCP. Now the DappNode knows how to use DappNode. You can just ask DappNode to use DappNode. Download this package. What's happening with the logs of this? And all of this can happen locally if you have a hardware that can run models locally, or it will happen by using a private confidential API that will do the LLM, that will do the thinking. And that's Nexus. Nexus, I like to think about Nexus like the Tornado Cache of inference. It gives you privacy in a certain way. There's locally, the first box is your DappNode, and you can run your local prompt there, you can run your tools, you have your data in there, and before you send it out, you can run a personal identifiable information anonymizer. You can remove the PII data and then send it out. The second box is our servers. We can also run a PII anonymizer there, just in case you're running whatever prompt somewhere else. And then we have a router, and all of this runs in a TEE, so we don't know what's happening, and you can verify that we don't know what's happening. The only thing that we're sending outside of the TEE is the number of tokens, so we know how much to charge. And then we send it to either an inference provider, that's what we call anonymous models, because they know they can read the prompt. We can't, but they can, because they need to process it. Or you can run it through a confidential inference provider. Why do we offer both? Because the one above is much cheaper than the one below. And for some other things, it's OK. And why do I say it's like the tornado cache of inference? Because it doesn't come from your IP. Even if they can read the prompt, it doesn't come from your IP. They don't know, they have no link to you. And if you've used a PII anonymizer and your data is removed, they don't even know that. They don't even know any of the data that you put in there. Right? And then if you really want the maximum assurance, you use a confidential inference provider. That also happens in a TE, and you can verify the whole chain of trust from beginning to the end. Right, those are an example of the proofs that you can get in Nexus, and you have to require to see the proof, to see the attestation, to see the verification. It looks something like this. We offer it in Nexus, but many private providers do not pass this test. They cannot provide you with this verification. All right, so what can you do when you have something private? We have a new teammate, and I am OK with giving it all the data of the work. Many of you are testing with this, but how many of you are not willing to give all of the data of your company to a model? I can do it. There's the DappNode brain. I give it meetings, Discord history, Grafana data, errors, support, and it even does PRs. It can automatically receive an error from our Grafana observability front end, and it receives the error, tests it, and sets a PR. And a human has not been involved. It will try to fix it. And it does task lists for humans, for agents. It does everything you want it to do. And I am OK with it because the data is always mine. There's nobody else that knows the data of my company. Right, so DappNode, you have plug-and-play hardware. You have open source software. It's this to install all these agents to make it work easily. And most importantly, private inference API, because sometimes local is not enough. Right on. I like to finish with this. I actually say this in every talk. Scalability isn't important until it is. Decentralization is not important until it is. And privacy isn't important until it is. Until you cause a fire. Until your insurance price goes up. Until your company does not have an edge anymore. Thank you. We have 1 minute for questions, I think.
Thank you, Paul. Do you have any question? We have, unfortunately, one question that we can take.
Wow, I've been clear. Fantastic. Sebastian.
So if I want to run this at home, is this going to be more expensive than my Ethereum validator? Like, how do I get this?
Right, so if you want to do this with your own hardware, the hardware will set you back around 4,000 euros. With VAT, maybe a little bit more. If you want to run on our inference API, the subscription plans start at 20 euros per month. And you get absolute verifiability end-to-end to make sure that nobody's reading this, not even us. And if you come to see me out there, I'll give you credits so you can get started for free. So come see me, come talk to me, and you'll be able to try this for free. Thank you.
Thank you.
Thank you.
What a good introduction. Before scale, there is security. Please welcome Raul Rumala, CEO at SafeLab, to introduce what comes after multisig and how to set up a continuous secure environment for on-chain team.
Hello, everyone. Hope you guys can hear me all right. My name is Rahul, and I'm from SAFE. Today, I want to talk about what comes beyond multisig, especially from how we are thinking from this lens of SAFE as a team, as a project, as our vision as well. And so my next 15 minutes, I hope one of the things I can impress you is with some insights, with a shared perspective and a collective information on what comes next. So I was here like exactly probably one year ago. So it's always nice to frame DappCon as this milestone, a retrospect in some way. So last year in 2025, I spoke about this philosophy that we were leading with at SAFE. We call it cipher price, which is how do you build enterprise scale demand, but built on the foundations and the principles of cypherpunk. So for lack of a better term, we call it cipher price, right? What has changed over the last 1 year is that thinking shift. That philosophy became habits, habits shaped our principles, and the principles shaped our product. So with that, an evolution in our perspective also about how things are changing clearly in the space. So I like to kind of like lead with an insight with a presentation when I have something. I try to do a lot of research, and this is this one insight that I have for myself, but also for everybody. In this AI-driven exploit era, right? We all know, we all see the stuff that's happening. The cost of performing an attack by a threat actor, it's just getting easier, right? It's getting cheaper, it's getting faster, it's getting more efficient. One of the most mind-boggling insights that I had was this insight from Mandiant, a cybersecurity firm by Google, is that they have this metric they follow, which is called mean time to exploit, right? They measure year over year as a trend. How long does it take to actually find an exploit? It's currently at -7 days. So kind of like let that boil let that absorb. So what does that even mean? A -7 days is time to exploit. So from my side, the way I kind of like interpret this is that it takes attackers -7 days to find a vulnerability before you can even patch it, right? So they are ahead of you essentially, and that's the reality. So like one of the things that I constantly actually think about it is what does that mean for me? What does that mean for SAFE? What does that mean for our industry, our users, our customers? And that one insight for me is it sets a really strong perspective overall. But ultimately, I boil this down to this one learning: like weak assumptions are easier to find, and the account setup, your posture on how you set up your assets, your control, your governance, that has to keep up. So, and further translation of this is that, it's very common in our day-to-day use of crypto. You know, we have our wallet, we use a Chrome extension, we use a safe, you use a module, you have a guard, you open a position in DeFi, you monitor it. There are lots of moving parts. You get on a new chain, a new L2. There's a very exciting yield position. You're moving your assets around. You're touching many things. All of these are audited, right? Like we have this best practice, right? Like there's a minimum bar of keeping things audited before letting users touch it, sort of thing. So what I see is this, by nature, our ecosystem is fragmented. It's by design, but also the security of this entire system is fragmented. And what this kind of made me realize is that being audited is just not enough. It's a great starting point, but it's not enough. It's sort of a proof point of assurance of a point in time. It's a point in time assurance. That's how I kind of translate it. Because ultimately, how our users using crypto or Web3 ultimately. It's workflows. It's you have a recurring transaction. You have to do payments. You have to monitor your assets. You have market making. You have treasury workflows, et cetera, right? So these are the workflows, and this workflow kind of mandates you or dictates your behavior in touching many things, and that's the behavior we have today, right? So at SAFE, we often think about this as the entire workflow, end to end, right? Where does it start? Where does it end? What is the actual job that a user or a customer is trying to accomplish? So for us, the goal is to kind of really raise the bar, raise the posture of the entire workflow, because you want to have confidence over the entire workflow, not like a checkbox that it follows a compliance or a certification or an audit. It's just not enough. We want the entire workflow secured. So one of the more interesting things of how SAFE has changed, actually SAFE kind of changed with the industry, right? Like 8 years ago, I remember myself, I had one SAFE. One SAFE became 2, 2 became 4, 4 became 8. A lot of people have many SAFEs that actually use us. This is something we see recurring on a recurring basis. Teams actually have multiple SAFEs. And that's pretty natural that I think as teams grow, SAFE accounts become like a system of SAFEs. And this forces us, when we're really designing a composition of SAFEs, that what do we want to express with our SAFE setup? In my head, I really often think about a SAFE setup in 3 controls. Ultimately, it's the control that I want to express with my SAFEs. The first one is positive control, right? Which is what do you want to approve? What do you want your system or your SAFE setup to say yes to? And the second one is negative control, which is what do you want to block? What do you want to restrict? What do you want to constrain at any given point? That's how we do it with guards and rules and permissions in place. And lastly is the delegated control. It's this concept of giving a delegated authority to another entity that can act on your behalf, right? We express that through a system called modules in the SAFE architecture. So ultimately, we, in my opinion, every team, and also us as builders, we ask these 3 questions, like what controls does it need to express? So now going back to the fundamentals, right? The way we kind of like think about this evolution on the SAFE system, a system of SAFEs, is that every SAFE should have a pretty clear bounded job, right? Like you have an operating balance, what it holds, what it can do, who is acting on it, and then what rules apply. Those are like the 4 fundamental dimensions that you can kind of like compose. And then ultimately what you want to express this is this entire network or a tree of SAFEs or a system of SAFEs. Ultimately, like you can have a very typical structure is you have a reserve SAFE, which is for capital preservation, or you have a payment SAFE, which is a high velocity transacting account, or something that's a bit more like DeFi operations, where you have higher thresholds for security and rules and permissions. So not all SAFEs are the same. And this needs to be reflected in this architecture of how you compose your stuff, right? The controls matter. Controls are not the same in every SAFE that you actually you set up and you interact. And that's the reality of it. Like we shouldn't treat every SAFE as the same and give it separate responsibilities. So, and lastly, I talked a little bit about delegation, right? The way we also think about delegation is when you delegate authority for something else to kind of act on your behalf, it needs to be really, really narrow. It needs to be visible. It also needs to be revocable. If you're giving that authority to something else, you need to be able to take it away as well. And that design thinking needs to apply when you set up and when you operate it and when you monitor it, ultimately. So again, so in a world, when we grow further, there will be more accounts, there will be more signers, there will be more chains, and that's, we know this is going to happen, right? How many of us have more than one wallet or one account? It's just something we deal with. Hell, we have more than one bank accounts even, right? So the takeaway that I'm kind of like trying to impress upon here is that you really cannot protect that you cannot see. So how do you protect something that you don't know what's happening? How do you protect something that you don't have control over, perhaps, because you gave that control away? And how do you actually look at this entire system, the entire workflow? How do you see it in one place? And this is the thinking that we're applying. And one of the big things that we're doing, like as of today, is this workspace, which is like your operating system for all your safes in one place, where you can stitch things together, apply, bring your team together. You have a shared address book, etc. But ultimately, teams are working together, and you are also perhaps a signer across many safes. You are operating safes across companies. That is a completely different workflow than our traditional models in place as well. And this is live today, and that's super exciting for us because it's a pretty big step to kind of have gotten to this stage, mainly because how we also grew as an industry. And something else that's been live for a while is what we call like Safe Shield. It's a Copilot. So in this AI-driven exploit era, one of the thinking that we have is we need a secure security copilot that sits right next to your transactions, essentially, that's telling you, is this malicious? Is this safe? You're interacting with this contract for the very first time. You don't know. We have not seen any proof of historical record. It's to kind of give you the confidence to operate your transactions. And there's two parts to this, actually. What we've been doing so far is actually a lot around the off-chain assurance, of off-chain confidence, with getting a bunch of rule sets from across the industry, working with multiple service providers, including our rule engine that's evolving as we speak as well. We call it Safe Shield, and that's a lot of the off-chain policies. And one of the other exciting things that we're doing is the on-chain security guarantee, or security on-chain enforcement of rules. We call it SafeNet. This has been a long time coming. For SafeNet, actually, you should attend the talk tomorrow from Richard, who's the creator of it. I think it's at 11. But one of the things we're doing is a Copilot Safe Shield will actually incorporate SafeNet as part of it. So you have the best of both worlds, which is off-chain guarantees and on-chain enforcement to get a complete picture. And the other very big thing that we've been launching is this security hub that we launched. So when you have a system of safes in one place, Security Hub will essentially give you a perspective into a score. We made it super easy for people to actually know if your setup is actually secure. You know, if you have an outdated contract, if your signers has a private key loss that's been reported, it's been labeled as malicious, you are using a third-party module that we don't recognize, and things like that. Especially when you have a system, an operating system of safes, like some of our users, when they have hundreds of safes, it's very hard to keep up with your entire security posture. Hell, it's even harder for you to delegate that to a security professional to come in and actually review it once a quarter or once a year. So this is live today, and I'm super excited to kind of like get this into the hands of user, because it's one step closer to kind of bringing more protection and more confidence for secure transacting in crypto overall. So based on these as foundations, where we're going next is to kind of complete this full assurance circle, I would say. One of the things we're working on is a lot about on-chain rules, on-chain policies. One of the most requested things that a lot of people have, and I'm sure a lot of people here also probably resonate with, is having a time lock when you transact, right? Like, if I'm doing a 100 million transaction, I can wait, you know. If I'm doing $1 billion transaction, I can wait. The friction is necessary. It doesn't need to be instantaneous. It just needs to work in the deterministic way that we need it to work. not only that, like we want to employ a lot more verification tools, like bring in cosigners to give you more confidence, have your own tooling system to kind of verify actually what you're signing is, that gives you really high confidence. And it's pretty typical into the best practice security workflow. And lastly is this cycle doesn't fully complete if you cannot monitor it, ultimately. You want to monitor because things are happening on our accounts when we sleep, right? That's the reality of it. And you want to have monitoring in place, but it doesn't really stop at monitoring as well, because once you have monitoring in place, you want to be able to employ things that can react to it. Right? You want to be able to react. You want to pull a position. If you have a pool that's too toxic, you have a stable coin that's depegging, you want to be able to react. And so basically, the risk posture is not just with your account, but also to your assets, right? And that entire thing is how really we're thinking about a full workflow. So ultimately, when risk changes either on your assets or your account, your system, your operating system, your controls should be designed in a way that they can respond, ultimately. So, and I will leave you with this last take, right? Like, I often think about beyond multi-sig is really what I'm thinking about future of self-custody. And it's not just that account setup and forget. It's actually, it needs to go continuous. And to me, the future of self-custody is continuous assurance, right? And the way I really think about it is like separating responsibilities. You set up rules, express rules, you verify it, monitor, and then respond to this ever-changing landscape. Ultimately, our mission is quite simple, and I think that resonates with a lot of people. We want to make self-custody easy and secure, not as a compromise of one or the other. And that sometimes it's harder than it sounds, or easier than it sounds for some people. But this is the one thing I want to kind of like express is we're in an era we need to really think about this entire workflow for us. And Safe Labs or Safe is really set up to kind of give that tooling and purpose and mission to kind of give users the confidence ultimately at the end of the day. So with that, I leave you for the next agenda as well then. Yeah, thank you.
Thank you, Rahul. Does anyone have any question? We have time for one question.
Yeah, thank you very much for the presentation. So I'm also I use Safe very often and have also a lot of safes. So I have one question. So I missed something actually. So all the data we are using in Safe and other wallets, we read from RPCs and so. What are your plans to do all this data, to verify this data, to have trustless data? Because if I have no trustless data, then all the checks might be critical because I cannot trust that this is really correct data.
Yeah, no, that's a great question. Maybe the way we think about it is a little fragmented. I have to dissect it a bit. So how do you know that you have trustless data, right? Ultimately, one of the design principles we have when we're building our products is not to make the choice for the user, right? Like we want to employ the user with a choice to kind of like express their needs, especially on the spectrum of trustlessness in the architecture as well. So today, like for example, when very simply put, like the Safe Shield that I spoke about, there are two parts to it. The trust assumptions are quite different. When you use the Safe Shield, which is the off-chain way to kind of like scan and give confidence, you are making a trust assumptions on our infrastructure for sure. But the SafeNet part is actually the more trustless part. And I think there are, from our lens, we are seeing a lot of trade-offs. When you really go with the deepest trustless assumptions on the stack, there are certain UX fallbacks or UX compromises that you have to make. And we try to always find this balance by actually giving that choice to the user to express, like, hey, this is what we can kind of provide, and you can interact with it. So for RPC data especially, we have our own indexer, for example, and you can run that entire stack self-hosted as well. And a lot of teams do this, and we maintain this quite openly as well. Pretty much all of Safe's code, most of Safe's code, I would say, is open, and a lot of it is open sourced already. So yeah, I hope that answers a bit, but this is how we kind of dissect and think about trust assumptions in the architecture in general. Oh, we got one more question.
Yeah, unfortunately, we would not have time, but maybe later.
Yeah.
Thank you so much. Thank you,
All right,
Raoul.
thank you.
He is a security engineer at Brave and co-author of EIP 6963 for multi-wallet interoperability. Among many contributions, he has worked at Brave Wallet, on-chain privacy, and key management standard. Today, he will talk about loose leader software and how it has become a key driver in the propagation of open source software. Please welcome Kyle Den Ortog.
Hello, everybody. Yes, so I'm sure many of you guys have heard about the concept of crops. So what I want to talk about is how do we balance it with the sustainability of actually funding it. So first, who am I? I'm a security and privacy engineer. I work at Brave Browser. I've also done open source development basically my entire career. Previously, I spent 5 years working on digital ID and open standards. So in that time, a lot of what we were building was kind of like base layer capabilities to be used. Originally, I got into the space in 2016, and that was actually just through buying and trading cryptocurrencies. And it was at that time that I realized that, hey, this party's not going to last. There's a lot of speculative capital that sits in here, and there's bull and bear markets that come with it. So essentially, I wrote a blog post about this just recently, and that's kind of where this talk comes from, is splitting it into two parts. First, how did Web 2 apply the concept of loss leader software? And then how do we apply it to Web 3? There we go. So to start off, I want to basically talk about how do we define what is loss leader software. It's essentially derived from the economic concept of a loss leader, which is essentially a product that's designed to get somebody in the door. So if you imagine a Thanksgiving sale or a Black Friday sale where they've got the TV that's $200 and you're how do they even make money on that? That is a loss leader. The whole design of it is get people in the door and then you can make money on other aspects of it. So when you apply this concept to software, it's essentially how do you acquire users? So if you can get users in the door, then you can somehow convert some of them into a paying user. And so what I want to talk about is why do we actually need these loss leader software? I'm sure many of you guys have realized that we still haven't achieved the next billion users yet. There's a yin and yang balance that occurs here between it, and in order to get that next billion that we talked about for years, you first have to actually bring the users on chain, and then once you bring them on chain, that's when you can try and derive value from their different usages and stuff. So in order to do that, we've done some parts very well. We've provided free open source software. It's loved. There's wallets, Ethereum, Bitcoin, all of these different sorts of things. They're different economic values that are serving real world purposes. So, you go to Argentina, you go to Turkey, you go to Nigeria, you go to Vietnam. There's people who are actually utilizing these technologies today for real purposes. So what we're doing is working. But at the same time, I've heard numerous people who are working and going, hey, I'm leaving this space. I'm not able to afford it. There's companies that are shutting down. There's trade-offs that are occurring because we didn't actually have a sustainable funding model. A lot of our operations have behind the scene operated on kind of an altruistic business model of like, hey, we're going to provide some grants or we're going to do some VC funding and hopefully we'll figure out the business model. But in the same way that Web 2 found that this didn't work for us, OpenSSL, Heartbleed, I would like to remind people of, we need to kind of level up how we're approaching the concept of the business models and distributing the actual crops that we want. It's all good that we want to be able to do the higher principles, but we need to do it in a sustainable way. So one thing I'd like to point out is that Web 2 was completely built on this concept. So the entire web as we see it today is largely funded by ads. But how did those ads get there? Well, first it started by Google producing a search engine that everybody loved to use. And then they added ads into their system. And like after year one, they generated $70 million of revenue back in the early 2000s. They continued basically cycling through that model and showing more ads to more users as they attracted them with the search engine. But eventually they reached a point where they actually got stuck. There was kind of a plateau effect, and so what they started to look at is how do we gain distribution of the search engine? When they looked at it in that sort of way, they started going, hey, there's value in us doing a partnership with Mozilla, and then also they looked at building their own browser themselves. So Mozilla is a free software. Anybody can download it. Nobody's paying for Mozilla in the same way that Chrome is a free software as well. And then this same concept continued on to Android as well. Android's not an operating system that we pay for. It's something that comes free with the devices that you're utilizing. And so essentially what's happening is this is creating this very large funnel that funnels people into their ads network. So Android operating system has something like 3.5, 3.6 billion different people that are utilizing it. And the defaults that are set is that you're going to utilize Google Chrome. And then Google Chrome defaults to Google Search, and then Google Search turns on ads. So you've also got Mozilla defaulting to Google Search, and that turns on ads, and same thing with Apple. So like essentially what's happening is this one key product is funding the entire web. And it doesn't just stop there, it also goes to like news sites. So anybody remember BuzzFeed and how they had a ton of ads on them? They were completely funded by ad. You ever been annoyed by YouTube? Yeah, that's all the ad revenue that they're generating as well. So like one key thing that we do right can essentially become an economic flywheel that just kickstarts the entire engine for everybody throughout the ecosystem. Some other things that I highlighted within the blog post as well that I think is worth considering is like, there is an open core strategy too. This has worked like auxiliary to the actual web itself, but like you look at Linux, nobody's actually paying for Linux, but there's tons of developers who work on Linux full time. Oftentimes they're doing it because the companies that they work on derive value from Linux actually being capable. So Microsoft pays engineers. There's entire companies like Red Hat that are built on the service models that are provided by Linux. There's conferences that occur, and there's like training modules and all of these different things that occur because of this open source software that's been like created. And so essentially like you can see these same sorts of like concepts applied in many different ways. Similarly, you can look at MetaMask. I think this is kind of the first touch point that I realized of how it applies to us is that swaps effectively built directly within a wallet are funding an entire team of wallet engineers. So if you look at MetaMask, they've generated something like $300 million in revenue just based upon swap value alone. So like that's a lot of money. And that's just their swaps. That's not the bridging. That's not the new perps trading that they have. But like you look at every sort of like thing that we're doing today, this is, I think, where we're kind of like fundamentally missing it, is that our user and our primary user is a trader. A trader is going to essentially churn themselves out of the network unless they're making money, and most people lose money when they're trading cryptocurrencies. So eventually, you've got a life cycle of it. You've burned through all your users. What do you do next? Who's your sustainable user that you keep around? So that's essentially what I wanted to cover here, is that like we don't have this like aligned incentives. Our primary like customer or user within this space is somebody who's just designed to extract value or bring value into the ecosystem and then have it extracted from them by others. That's not a sustainable revenue model in the same way that like a bank operates. Like most people don't walk into a bank, sign up for a bank account, and then lose all their money and 6 months later leave their bank. But for some reason, that's what we do with their wallets. But there is some other aspects that come into play with this. So the growth was dependent on factors outside of the founder's control. So essentially what happens is that like the distribution that occurs from this, from the wallets and people showing up, oftentimes the incentives aren't aligned with those sorts of like goals that occur. So yeah, essentially where I'm going with this is the idea that like if a wallet is designed to make it easier for somebody to trade, but then they're being incentivized by VCs to like hype the token that's being launched, or a protocol is being incentivized to hype a token that they're launched, then that's actually re-incentivizing the wrong problems that we shouldn't be thinking about in the first place. Similarly, so I think everybody's experiences this. We've seen this right now too. Public good fragility is a real thing. Infrastructure starves when markets dip. So you look at like what's happening with the EF right now, a lot of it comes down to the fact that Ethereum value is dropping. There isn't a sustainable model for the Ethereum Foundation. They've accepted that, that's all right, but who funds the projects that happen after they're gone? That's the question that we're faced with now. So this is the second part. One of the things that I've realized as I've worked on wallets for quite a while is that wallets act as the distribution hub. We are kind of the central point in the same way that a search engine is the distribution hub to the Web 2. And so with that, the wallet acts as a way for you to be able to access and utilize the different protocols that occur. So you want privacy. It's much easier if you have it built directly into your wallet rather than having to show up at a website and try and figure out, hey, has it worked? Oh, wait, I need a different wallet. Wait, my money is on a different network. I need to go swap. Wait, there's different sort of trading things. Like that was an actual experience I just had when I wanted to go donate $100 to Roman Storm's fund. I did a UX just like analysis on myself. It took me 34 minutes to onboard myself and actually donation, and I had to go through 8 different sites, generate 2 different on-ramping events, and I had to do multiple transactions for it. Like, we've essentially built a model where all of the protocols exist from the web's perspective and from a browser's perspective in untrusted land, but an extension is considered trusted. And so this is kind of the way that I've been thinking about it is the wallet is the loss leader as it exists today. It's a piece of free software that we can utilize. It's already extracting some level of basis points, and I do think we should get better about what we're doing in order to be more competitive, but I'll cover a little bit more about that in a few slides. But essentially, the wallet becomes that distribution engine that you can then build on top of and generate more volume through. So how do we balance it? And like, what does this look like? I don't know, show of hands here, who's actually built a protocol and tried to build a snap, a MetaMask snap? Has anybody done this? 1, 2? I'd venture to guess you guys didn't have a good time with it. I've spoken with many people about this. As somebody who's looked at it and understands the underlying technology of what they're trying to do, I think they've actually built a model that aligned with the web paradigm much better than we realize. It's just not been done in the right way. So one of the things that we're actually looking at within Brave Wallet is how can we reutilize the snaps in order to improve the security and make it easier for protocols to be able to access this. So the idea here is that, like, as a wallet, we don't want to have to go and build an integration for every single protocol in order for them to get distribution. But what we can do is we can build a defined set of interfaces so that any wallet protocol can plug in and just generate the transactions on behalf directly inside of the wallet. And so that's essentially what a snap is doing. There are security trade-offs that come into play. So as soon as you build in the extension model of any sort of paradigm, this happens within a browser as well. Essentially what happens is the extension becomes trusted in a way that could be manipulated. So if you download a malicious extension, that can become a problem. But what we're doing is we're actually solving an adoption struggle for the protocol developers. No longer are they having to come to wallets and do a BD sale where they're doing a rev share split each time in order to try and get their protocol adoption and grow the liquidity. Instead, we're just saying, hey, go and build it, show it works, and if it works, we'll continue to market it to our users and continue to grow it on your behalf. And so this is the thing about it is like there was a talk or a blog post a few years ago called like the fat wallet thesis. And essentially what I've realized is that's already here. The protocols are already coming to us. They're coming and asking us to add their protocols to get the distribution and then to align it with their goals. Essentially, we're doing the rev share splits. That's how the wallet industry is being funded. And so this model is actually working in such a way that like we should look to figure out how we should realign the architecture of Web3 to make this work a little bit easier. It doesn't mean we need to get rid of window.ethereum. It just means we need to refine how snaps are working in order to make that a little bit better and to make it easier for these protocols to come into place. So the nice thing about this too is that like no longer do you show up at 14 different sites in order to complete the actual one journey that you're wanting to do. It all just gets abstracted into the wallet. All of a sudden you're able to have one snap talk to another snap and your user journey just becomes, hey, I want to send money to this address and I want to utilize these tokens here, and I can figure out what their token is and what they accept. Maybe they publish it on an ENS record of like what their preferred token is, and I just say send money to ENS, and under the hood my wallet's automatically doing a swap, a bridge, it's running it through a privacy protocol, and as a user I don't really need to care about that because all I cared about was the intent itself. Similarly, so it makes it easier from a wallet perspective to simplify what we're displaying to the users. We don't need to take some hex data and try and figure out how to parse some data that's for some new protocol that we've never even seen before and display it to the user what might happen with that. This is like half of the problem that we have as wallets, and one of the things that Drainer malware is actually exploiting is the fact that many times a wallet doesn't understand the actual transaction data it's trying to display to the user because it's a new protocol or because they're doing something esoteric like basically burying call data inside of a multi-call, 40 calls deep, and then all of a sudden the wallet is expecting to parse this in a very different way. So the nice thing about these snaps is it also shifts the direction of kind of the security that we get. And so we get essentially a minimalist architecture from this, and we realign with how the web works in that direction. Again, we're going back to the site itself is considered an untrusted process. As a browser, we literally give it its own separate process. It gets its own separate memory. We don't let that memory talk to somebody else's memory, and we have a separate browser process. Same things with extension is it's treated in a higher fashion because the user is downloading it. That's essentially what we're trying to do in order to achieve that. And because of this, we can actually probably reduce the supply chain because you don't need all of the UI capabilities. They're already built directly into the wallet itself. This is just a part of like the MetaMask design that they've come up with. But there are still things that need to be improved, and this is why I asked that. Snap extension stores are still going to be part of a problem. The wallet needs to create a Snap extension store, and it needs to be actively marketed. This helps the protocols in some ways, but it hurts them in others. If there's, for example, some reason it needs to be taken down because it's not certain if they're malicious or not, these are the sorts of like dirty trade-offs that we have to figure out still. But ultimately, where I'm trying to go with this is that essentially, if we rework these business models and we make it easier to get more users on board, we can actually generate more transaction volume, and the larger amount of transaction volume that we can generate, the more revenue we can generate, and that means we can have more engineers that can actually afford to pay a salary and be able to continue to do it. What we do with those profits is the bigger question. I think this is what the EF is trying to signal to all of us, is to say, The goal is don't make profit. Instead, it's focus on the crops, and there is an aspect that's useful to that, but there is a life cycle that will eventually die because of it. And so this is part of the reason that I point out the Friedman doctrine is essentially you look at the economics of today and this idea of like monopolies, a lot of it comes from the concept of what he was promoting, and I say it's time for us to challenge these things when we're building out this new web. So if you want to read through any of these blog posts, the first one is mine. There's other people who are talking about these ideas too and challenging my theories or presenting new ones. I highly recommend people take a look at these as well, because ultimately we're not going to be here in 10 years' time if we can't find a sustainable way to do this, or we're going to end up back in the Google model of don't be evil turns into, oh well, we'll just collect all your data.
Thank you, Kyle. Thank you. Unfortunately, we will not have time for questions. Let's kick off the last for the morning. He founded the Institute of Network Cultures in Amsterdam, and he is here today to present projects developed within the Institute, as well as his book, Platform Brutality. Where is platform theory today? What happened after the never-ending phase of internet regression? Are you also stuck on the platform? Please welcome Geert Lovink.
Hello, everyone. It's a pleasure for me to be here and present the work of the Institute of Network Cultures in Amsterdam. This has been running for 22 years. We're probably known in this context for our a network called Money Lab, which started in 2014 and is still running. This is the website, a WordPress site. Due to my mandatory retirement in a few months, we have decided to continue the center. Here you see our streaming, live streaming activities together with Ukraine TV in Krakow and many others in Ukraine and Eastern Europe. This is a very lively network, and we see this also very, very much as an alternative for the social media blues, especially amongst Gen Z and young users, which is so widespread. Here you can see some of the topics that we are dealing with right now and will continue also as an NGO when we start to have our new phase. And this is a project quite soon, again here in Berlin, the Solidarity Economies Lab, which will happen here in October to January here in Berlin as part of the Transmediale. But this time I would like to speak and read some parts from this new book that I recently launched. It's called Platform Brutality. After Sad by Design and Stuck on the Platform, I see this as a third book that really deals with this implosion that we are confronted with, no longer hypergrowth or facilitation, but really the internet is turning into a violent environment for many. And in this text and in this book, I'm trying to explain this turn to this new condition in which so much AI slop is generated, and this is reflecting a very, very different approach amongst users, which is a very sad situation that is turning into this structural or abstract violence. And we know from experience that the abstract violence and the structural violence that people nowadays associate with internet platforms will eventually turn into real violence. And this is the issue. So I'm going to read here some parts. I've constantly updated this story because it's really happening. So this text goes well beyond the book. And in the meanwhile, you can look at the memes that I've been collecting and creating myself. So the stagnation of the platform has brought us back to the military origins of the internet. What happens when mindless and distracted users remain stuck with no end in sight? The destruction of attention starts to hurt, eventually turning into structural violence. Platforms are the unseen and behave like innocent bystanders, pretending never to be responsible for anything. They were intended for users to look straight through them and not notice their design anymore, thanks to mundane and smooth functionality. Transparency makes it hard to see them as distinct objects. Right? So this is really difficult. What is a platform? Even this very simple question. Users that are on them 24/7 cannot really answer this question. Right? They do not shine. The platforms do not shine, to put it in the words of the late Dutch architecture theorist Maurice Niel. So, despite the urgency of the platform question, the problem cannot be addressed head-on. Until very recently, invisible facilitators of platforms appeared as pure ideology. People could not see them. Not only did leading players quickly become too large to handle for local players, platforms turned out to dissolve into thin air, hiding inside a technical stack, becoming an ecology or a stack, an unaccountable sphere, much like the air we breathe and do not notice. Both users and experts find it hard to explain where platforms begin and end. As politicians are unwilling and incapable of breaking up big tech, the internal hypergrowth mechanism keeps generating new market behemoths. And this is now, of course, moving into AI, but I don't need to explain that to you here. The platform condition is classified by everyone as intolerable, unlivable, uncurable, and unbearable. There's disgust translating into disdain for the topic, right? The platforms cannot be dealt with. They've been around for 10, 15 years. We don't know what to do with them. So, a cynical reason emerges. Everyone agrees on the untenable power of the platform, yet no one is willing to leave. Mentally speaking, the users have been proven incapable of facing the information. Glued to the phone, users cannot even notice they're logged in. In a matter of seconds, they have liked this, purchased that, responded to an emoji, created one themselves, and hovering over the apps, the mindless online presence has turned subconscious. The purpose of the platform is to do what it does. No higher goal or problem needs to be resolved. Once you've created a profile and clicked on something, the endless scroll takes over. From the moment you've signed up, the platform presents itself as a self-evident totality, a service that was, is, and always will be ready to lure you to the next transaction. Now that you're part of the flow, any attention hook can pull you away. There's no longer the tiring obligation to build one's own social network. Just start swiping and the suggestions will appear automatically for your eyes only. The term platform brutality, the name of the title of my book, was instigated by the African philosopher Achille Mbembe, who published a book in 2020 in French called Brutalism. The thesis here is that instead of being portrayed as a machine of endless facilitation, the internet has hit a historical wall, and in response comes up with an inner destructive energy, right? An energy that maybe in the past was going outside in terms of endless growth, but now is turning against itself inside. Yeah, implode or explode. Maybe you remember that meme. As planetary machines in a murderously frenzied state, platforms are at full capacity of mobilizing resources. So the platforms have, in fact, not yet declined or have disappeared. Quite the opposite. They're operating at maximum capacity. Loaded up with this potentiality, the platform used to present itself as a never-ending thin layer with which the techno-social is acting itself out. But this image can no longer be maintained. As a vast plane lacking depth, the platform facilitates a never-ending one-dimensional trip that is impossible to quit. As lost subjects endlessly toil around in it, digital reason has a hard time explaining the matter. And now I want to turn to an example that recently I studied and described. And this is the saga of Doge, right? And Doge is really very, very interesting example. And it's modeled, of course, after the takeover of Twitter in October 2022, when Musk moved in and destroyed the company he had just purchased himself, right? And so he took those experiences and thought he could scale them up in order to destroy, let's say, government bureaucracies, programs. Of course, US aid is the most, well-known example of a department that he single-handedly, closed down and destroyed in a matter of weeks. And it is estimated that, as an example of platform brutality, that within a couple of months, the Doge operation, meant that 300,000 people lost their jobs. Now, what is very important here is how this was done. And for this, I ask your attention to this theory, and that we really need a philosophy of what it means to delete. Right? Of course, hackers that invade your system, they know how to delete. But how to scale up, how these days deletion as a mass practice, mass deletion is practiced, right? And so when we're talking about abstract violence, structural violence, the act of mass deletion is becoming more and more important, okay? So, of course, it's part of modern warfare, but we find it, in fact, in any system. So, an example of today's abstract violence is the strategy of mass deletion. Digitally erasing entries of the other is both symbolic and literal, right? So to delete someone, has multiple, let's say, layers and implications. The public gesture of canceling individuals or calling out groups, remember, that's still the old-fashioned cancel culture, right, is not enough. And often this is only stage one in a process leading up to large-scale eradication, right? So deletion is the technical manifestation of a cold act and not just a moral condemnation, right? Which it was somehow seen, in the days of cancel culture. It was Elon Musk's Department of Government Efficiency's main weapon. As a cultural technique, digital erasure is really next level and goes beyond censorship and budget cuts, or what in our circles here maybe we would deal with under the rubric of privacy, etc. Right? This is really next level. To silence or to hurt is one, but to kill the file is another. So blotting and blacking out can still be read as a correction, but we're not talking about correction here anymore. Editing should be an improvement, right? Mm-hmm. Do good forces love to clean up and restore order? Yeah, we all love that every now and then. It's necessary when we clean up our files, of course. Everyone needs crucial access to data to cross out identities and related resources indefinitely. And indefinitely is important here because we all know that, of course, once you erase data, they can very easily be installed again. If you have a backup, right, you come back the next day, install it again.
Another example, on Cello, there is this self protocol, pretty cool protocol where you can take your passport and kind of scan it with your phone and make proofs that in your passport, whatever, you have a specific nationality or you have a specific age. And that would be quite nice to combine this with the Circles Trust Graph. But again, it's such a pain to do it because they are not on the same chain. Last example, Euro C liquidity is quite strong on Base. We have Euro E liquidity. Wouldn't it be nice to kind of share this liquidity and have overall then stronger euro liquidity against Ether and dollar stablecoin? But again, it's fragmented. So there's some liquidity here, some liquidity here, some liquidity on Ethereum, and it's all a mess. Again, why is it a mess? Because ultimately those layer 2s or those other chains have essentially very slow communication with Ethereum, and that is kind of the seven-day settlement for Arbitrum, it essentially takes 7 days to settle the state of Arbitrum to Ethereum. So if you would want to go the proper path of using the canonical bridges, it would take you to kind of go back and forth from Gnosis, or to just implement the things I just described. The communication between the chains would take many days, and it's completely impossible to build an app. So you would need to fall back on third-party bridges, but then again, you have a fragmentation. They might only support a subset of those things. So it's overall a total mess, and Ethereum, therefore, and I think that's a big reason why why Ethereum is in the position it is in, where it's, where it's certainly not been as successful in adoption of protocols and of dApps. It's certainly not as successful as we would have wished it to be. And yeah, I very much blame this level of fragmentation to it. So what is, where's EEZ going towards to? So EEZ will essentially be a set of chains that are much more tighter connected to Ethereum that essentially do what we call real-time settlement. And real-time in terms of Ethereum means every 12 seconds, because every 12 seconds there is a new Ethereum block. So if you settle if you settle your chain every 12 seconds, you are essentially kind of in real time with Ethereum. And now things change dramatically. Now essentially all those chains that choose to kind of join this economic zone, they can do instant transactions back and forth. And kind of technical term would be they have synchronous composability. So in the first step, those are two chains. Well, Gnosis will move into this EEZ, and we are building a project that we call Rollup 1, kind of the first proof of concept, or more than a proof of concept, but kind of the first instantiation of a EEZ chain. So those are the very first chains that will join this EEZ. But of course, the potential hope is, or the path should be, that any chain that wants to join, that essentially those network effects can join the EEZ, and then it overall becomes this much stronger place where innovation can happen again, and just more positive network effects happen. So again, today it's quite complicated to launch a new chain. If you launch your new chain, there's still so many pieces you first need to get on the chain to make it attractive for developers to build on this chain, because you need different stable coins, you need different on-ramps, you need price oracles, there's a long list of things that are basically, before you even can start building interesting stuff. And in this new EEZ world, you could launch a new chain that is EEZ enabled, and by default you already have everything available, all the tokens, all the protocols that are available on Ethereum. You by default can already plug into them, and you can really add to it instead of first rebuilding what was already done. So first you benefit from the network effects, but then in the next step you also contribute to the network effects. So right now, even if a chain overcomes this hurdle and then becomes successful, then it becomes successful on its own, and it's essentially still its own ecosystem and its own cosmos, and it's not really contributing to this overall thing. Again, this would change with the EEZ. So one more perspective on this. So the promise was made quite often. So I think I'm certainly not the first one telling you, okay, this is how we fix interoperability. So there have been many attempts to say, we are doing shared sequencing and we are doing this zone where we will have this interoperability. I think the big difference is that we put Ethereum at the center. So if you build a new protocol that says, okay, within this protocol, you will have shared sequencing and you will have the synchronous composability and so on, then of course that is only useful if many projects join that zone. So if you're the first one, then, well, congrats, you have synchronous composability with yourself, and then, well, okay, maybe you can convince someone else to join, but then you're still a small subset. This is, again, different with EEZ, because the first chain that already joins EEZ will have this synchronous composability with Ethereum, and that's immediately already a huge value add. So it basically doesn't have this bootstrapping problem of first requiring enough chains to join before it's useful. EEZ is useful from the very beginning because Ethereum is part of it. A bit technical slide. So I mean, there are many concepts, and I just wanted to quickly say, so there is the idea of based rollups, so essentially rollups where they don't have their own sequencing. And there is the concept of native rollups that I introduced at DappCon, so essentially a rollup that doesn't have its own token, that basically just, I mean, is as neutral as possible and kind of is basically just an extension of Ethereum. And then there is EEZ, which essentially means you have this, real-time settlement on this synchronous composability. And you can combine all of those things, and that is what Rollup 1 does, but you can also still, and this is what Gnosis is going to do, you can also still have a sequencer which means faster block times and other things. So yeah, there's no full overlap, but there can be overlap between the concepts. So one more question I sometimes get is, should we even have L2s anymore? Aren't we in a place that L1 is scaling, and that basically just everything should live on L1? And I would say there are 4 arguments why we should still have L2s. And number one is simply still costs. So those are the costs I took from today. So a swap on Ethereum costs, plus minus 15 cents, borrowing the same. And those are basically, and then that's great. I mean, kind of, we used to have costs of $10 or something like that for a swap on Ethereum. So 15 cents is great, but there are still many use cases that require significantly lower fees. So our Gnosis Pay card, where you do I don't know, I mean, you can buy your coffee for $2 or $5, and this triggers essentially an on-chain settlement and potentially even a swap, because you might want to swap your interest-earning tokens then into the token you pay with. So basically, such a transaction cannot, for this specific use case, can certainly not cost 1 cent. It definitely needs to be below 1 cent, and 15 cents is completely impossible to build that. So that alone means many use cases are not feasible on Ethereum L1 just because of costs. The second is, of course, speed. Ethereum has 12-second block times, and again, for many use cases, you want to have faster speed than 12 seconds. The next one is still, number 3 is still what I would call distribution. So we saw this concept that many let's say centralized exchanges want to have their own L2, and I think it kind of makes sense. So they can basically, I mean, in a way, it's one way to think of it is to say it's a franchise model. So they can kind of take what Ethereum essentially built and have their own version, and in that they can have their own, try to use their existing distribution channels to get a user base on it, and they can take a cut essentially from the fees, or they can have other business models. But it still, and again, this changes with EEZ, it still feeds back in heavily into Ethereum, and because as soon as you do then transactions with Ethereum back and forth, you strengthen Ethereum, and again, it strengthens the network effects. And the argument number 4 for L2s is neutrality, or in a way the opposite of neutrality, being opinionated. So I think Ethereum, and I think we all agree about that, Ethereum should be the place that is absolutely neutral. But being neutral comes with a cost. And I mean, the obvious one is in the case of hacks. So if there are hacks, and unfortunately there are still way too many hacks, it comes with a big cost of being neutral. So basically saying, no, we are not hard forking, we are not censoring, we are basically letting the attacker go away with, the hacker going away with stealing money, essentially, is a big cost, and or is a big trade-off. And again, I think it's correct that Ethereum, stands here for this, or is this anchor piece of credible neutrality, even at the cost of essentially letting hackers get away with hacks, but I think there's definitely room for L2s to have different opinions and to say, for example, on our L2, and so what I'm suggesting for Gnosis, to say, well, we are opinionated in this case, and we say if there's a large hack, we are, in a way, we are not neutral, and we are trying to then have processes in place to revert that, if in any way possible. So now let's look a little bit in the technicals. The next talks from Jordi and Philip will go more into it. But just to give you an intuition of, a rough intuition of how it technically works. There are two major components that are required to become essentially an easy chain. And the first one is real-time proving, or at least a real-time commitment to your state. So you cannot basically, as Ethereum, you basically need to, within the time span of 12 seconds of a new Ethereum block, you need to commit to Ethereum what your new state is going to be. And you also need to kind of commit in such a way that you cannot go back from it. So if you want to do this in a trustless way, then you need something like ZK proofs. So you basically make a proof that this is your new state, and you also prove that it's correct, but you can, of course, also use methods that assume some level of trust. So it's sufficient if whatever, with TEs or with even a multisig, as long as there's a firm commitment, this is our new state, and you have this commitment fast enough, that's kind of the real-time component of it. That's the component number one you need. The component number two you need to accept that Ethereum is the ultimate source of truth. And that means if you made this commitment on Ethereum, then it's binding, and usually Ethereum goes only forward. So basically you make this commitment, then it is what it is, and then kind of in the next block you make a new commitment. But once in a while it happens that Ethereum reorgs. So once in a while it happens that you commit something to Ethereum, and then Ethereum kind of forgets about this block. So this happens roughly 3 times a day that an Ethereum block was created. But then a new Ethereum block is created, but it's not building on top of this one, but it's instead building on the previous one, what we call a reorg. And that happens roughly just 3 times a day. If it happens, you need to kind of accept that, or your layer 2 needs to accept that. So you committed already to the state, but this was forgotten. So potentially you need to reorg as well, and you need to, essentially you need to follow the reorgs of Ethereum. And generally speaking, that's quite doable, but it is something to keep in mind. So again, 3 slides now, a bit trying to give you an intuition of how it technically works. So let's say we have Ethereum block 100, block 101, and then 102, and those are anticipated blocks at this time. So we are here in time, we see this block, and we anticipate that those blocks are coming, and essentially, thanks to the beacon chain, they come at predictable time slots, 12 seconds in the future. So essentially, we have to do a bit of time traveling. So we are here in our L2, and we basically already here, so let's say 6 seconds before this block actually happens on Ethereum, 6 seconds before, we have to already peek into the future and say, okay, we are doing a block here, and it will have transactions that in a way only happen in 6 seconds in the future, and they will happen in this Ethereum block, and we need to anticipate already what they do. So again, we have here, for example, a user trying to make a trade on Ethereum, so starting on the layer 2, sending some tokens to Ethereum, doing a trade, and getting some other tokens back. Then we need to anticipate what this trade will look like in 12 seconds, or in 6 seconds, and already kind of continue our chain with the anticipated result. And kind of then essentially commit to this, and then see if that transaction, that settlement transaction of essentially the settlement of our L2 state actually works the way we anticipated it. And if it does, great, then we are in this state. So things can get complicated here, but so just roughly an overview. So of course, it might be that that this doesn't happen because we don't, or from the L2 perspective, you're not fully controlling Ethereum. So you might say, okay, I want this transaction to be in the next Ethereum block, and I expect it to have this result, but things can change. Someone might get a transaction before you in, and then your transaction does not have the expected result. So there are tricks you can do to essentially kind of test or deploy or try to execute multiple versions in parallel and basically say here's a settlement, but if that doesn't work, then I can use this one, and if that doesn't work, then I can use this one. So you can then basically say, okay, there are a bunch of transactions that are unaffected regardless of this, and I can always confirm them. There are some transactions that depend on whether they get into Ethereum. The whole thing gets then complicated once you have multiple EZ chains, and you have those blocks that sync with Ethereum, and you might have some blocks in between, and you might have, but too much for this talk. But just as a kind of in depth, things are of course a bit more complicated. But okay, so last two slides, I believe. So number one is just again step back. Who or what is required to make EEZ happen? And the good answer here is no one. So we can do it right now. We don't need any hard forks. We don't need any buy-in from someone. We can just permissionlessly build it, and we will build it. Of course, there are a few entities, and specifically builders and validators, validators who ultimately control the settlement of Ethereum blocks, that if they work together with EEZ, it can make the whole thing I kind of tried to describe in the previous slides easier, because it becomes more predictable that your L2 chain can actually do the settlement it expects to do. So one last one is, I already hinted at it, yes, Gnosis will become an EEZ chain, but in parallel we are doing what we call rollup 1. And just a few comparisons. So we will rollup 1 will be fully based, so just using Ethereum timestamps or block time 12 seconds. We'll have Ether as gas token, but on Gnosis we will keep extra. I use 2 seconds block time, so Finally, very last slide. Very rough timeline. We hope that by the end of the year, we have Gnosis with limited EEZ functionality, so with the ability to do synchronous calls, but not. I mean, you can do very complicated synchronous calls that go back and forth, and maybe we'll start with calls that only go in one direction or only have one return value. We will still try to bring concrete, tangible advantages to Gnosis earlier, and in parallel, we are developing this rollup 1, or started as a testnet on Ethereum, and it can, as rollup 0, and it can turn over time into a rollup 1. So bottom line is, in summer, hopefully we have something that's already live on Ethereum. By the end of the year, we have already functionality to Gnosis, for Gnosis chain. Okay, that was my overview or introduction to EEZ. Thank you.
Thank
I am
you.
afraid I'm short of time, or one or two
You can take questions.
Okay.
You can take questions.
Then I'll happy to answer questions. I think I see here. Or maybe we start.
Great talk. How confident are you that all these issues, technical complexity, everything is solved, and there's not something coming up which breaks the whole thing?
Pretty confident, because we have in a way created proof of concepts end to end. So we have tried everything I described here. So yes, it boils down then to what level of reliability can we get to. But here I would say the whole Ethereum block production process has already shown that you can go to a high level of reliability despite all this complexity. So if you just look at what the complex flow is of building an Ethereum block right now with relayers and bundle merging and builders and I mean there's a whole it's a really complicated process and it works extremely reliable. So I would say those two things to me are proof that we can do it.
We have time for maybe one more, if we're quick.
I think there's.
Just here.
Someone get you a mic? No. Okay.
Much like the European Economic Zone, I guess you have to do some lobbying to get people to join. Like, what is the general reception amongst the, let's say, incumbent L2s and such?
Yeah. Right. So the question is, do we need to lobby people to join? So the good thing is, I think that in a way we want people to join, but we also don't care that much because, essentially as soon as Gnosis joins, we already get a huge advantage for Gnosis because we are fully compatible with Ethereum. And if others want to have this advantage as well, then they should join. So we don't need others to join to get an advantage out of it. That's point number one. But then maybe still kind of thinking about when does it make sense to join. And then I would say, yeah, I admit kind of for large ones, and that's maybe right now it's probably Base and Arbitrum are probably the chains that have sufficiently created their own ecosystems. For them, it's maybe slightly less interesting, or at least because they are in a way already strong enough. But for all other chains that struggle with having enough liquidity, having enough stuff, for them it will be a big benefit to say, okay, finally I don't need to spend all this money on trying to create incentives for liquidity, on paying oracles to integrate our chain and so on. We can just plug into this and then essentially use Ethereum. So long story short term I would say it's most interesting for chains that haven't reached escape velocity, but definitely I would say long term it should be interesting for everyone to kind of benefit from the network effects.
Great,
right.
Thank you very much, Martin. Next up, we are very pleased to welcome Jordi Bailina to the stage. So those of you who don't know Jordi, Jordi is leading the technical development of the Ethereum Economic Zone. He is also the founder of Zisk. He is unarguably one of the OGs in Ethereum's technical community. He and his team are behind the developments in real-time zero-knowledge proving that have enabled synchronous composability. Jordi Bailina, welcome.
Well, hello everybody. Today, let's know if it works. Yeah, today I will divide my presentation in first a small update of the status of Zisk, and then I'm going to go a little bit deeper in how to build the easy proof, especially for the proving systems, how to use this to build the easy proof and see all the advantages that Zisk have to build that proof and what are the challenges that are there. If we talk about Zisk, as many of you know, Zisk is an open source ZKVM. It's based in RISC-V, 64 bits. It's fully open source. It's fully quantum resistant. It's 128-bit security. And today we, I don't know if this works. Yeah, today we are announcing what's Zisk 1.0 alpha. So 1.0, what it means is, we just freeze the code. We say it's alpha, so everything is there, everything is in place, everything can be used, UX is used. We don't want to call it like a final, we don't want to remove the word alpha because the security, I think we believe, we strongly believe in security and we are not still 100% confident. I mean, we just changing some lines of code a few weeks ago. So we are not 100% confident that there is no soundness errors and so. And in today's days, AI is taking an important place for auditing by formally verifying all these smart contracts, and this is very much the current work that we are doing right now. But especially for projects that they are building their own proofs, system is there, is available, you can start using, and yeah, we believe that's quite deliverable, except for this auditing that's going to be the main work for the next month. Okay. We're also introducing what's kind of a toy, but it's a Zcath1. This is a full Ethereum client. It's a stateless client, and it's optimized for Zik. Actually, this is with this client proofs can be so we get between 10 and 50% earnings in proof cost, and is full client designed from scratch using AI. I mean, it's interesting to mention here that right now writing a full Ethereum client in 2 weeks is crazy. It's a crazy thing, but something that you can do it today. Okay, okay. Let's go to the easy proof. Okay, so well, Martin already explained what's easy about synchronous composability. You know this challenge here. So what happened? So when we're talking about the synchronous composability, what's really happening here? Well, what's happening is that we have one call at some point. So we have one transaction that at some point is calling a smart contract that's another chain, and then returns and continue execution. So we see this kind of context switching. I mean, you are running in one chain, you context switch to another chain, and then you go back to the other chain. So easy. So in easy, mainly what we do is we collect all these context switching between chains, and we can put them in a lock. I mean, it's also all the things that sequentially are happening. So I start a transaction. This transaction is doing a call to another chain. This other chain do a return, and then we end the transaction. Okay, and we can set up this in a lock. You can understand that this is going to be in the blobs. Okay, and all these calls, I mean, or returns, all this context switching, you're going to be in a blob, okay? So that they actually, and if we summarize easy, is we have current states of the rollups. We have these logs of things that are happening, can be transactions or calls between calls, and we just want to prove that these state transitions that are happening in these different chains are consistent with the blobs that are there. Blobs are well format, are consistent, and all these generate the places. And of course, when these calls affect the L1, because everything that happens in L1 is actually executed following the same rules. Okay? But from the proving perspective, this is very much so what we need to prove. I mean, this consistency between the states that we are changing and the locks that are happening here. Okay? This is a more complex idea. So here is, instead of having one roll-up and one call, here we have 3 roll-ups, each one calling one another, and with nested calls, and you can add even an extra thing here is that can be reverts. I mean, these calls can revert, so maybe there are some states that they just need to revert to some specific state. So things are a little bit more complex, but at the end, it's just a lock of things, of context switching that are happening. Okay? Another important concept, I mean, before going deep to the proof, is the idea of the state transition function. Here is we call it action-driven state transition function. With it's a very specific. It's a little more deep. I mean, in a normal chain, you have a state, you process a transaction, and you get a new state. Okay. In this case, we don't have only transactions, because I mean, when we have a call, I mean, this is not really a transaction. It's just each of the pieces. So it's a piece of code that's executing in a given moment. So I'm doing a call, and maybe the result is so the end of this action is that this call is not a return. It's maybe calling a nested call in another chain. Okay? So we have this idea of, so we have an action that can be a call, it can be a return, it can be a same transaction, and you execute something, you change the state, so something is happening here, and then you get a new state, but you get another action that happens continuous. Maybe this action can be an end transaction if it's the end, but it can be maybe another call or a return to the previous call. Okay? We have also, I'm going to pass here, we have also some revert info that this state transition function can give if there are some reverts that happen there. But this is important. So, and this is very much what a chain needs to define. I mean, these rules is what a new chain can be defined. These rules can be Ethereum if it's an EVM chain, but it can be maybe a WASM chain, or it can be any sort of chain. The nice thing of Easy is that each chain can define their own state transition function, and it's full control of this. Okay? So if we see the call, I mean, if we see the proof and the things that we need to prove, it's mainly we need to prove three things. Well, the first is we have these blobs. Okay? So we have these locks of context switching that are happening, calls, returns that goes from one place to the other. Okay? This is a blob, so we need to parse these blobs. So we do all this is encoded in blobs. So we need to parse these blobs. Okay? Check that the consistency, everything is matched so that there is no lost calls, and so that everything is correct in there. Okay? This is what each blob proof. So we can have a blob, and then I get a blob proof, and then the consistency of these blobs. Okay? The other thing that I need to verify in chain is these action-driven state transition functions. So I want to prove that each of the individual contexts. So it is these green squares there. So these parts are essentially correct according to the rules that the chains define. All these chains, they define it via a verification key of a specific circuit. Okay? So this is the ADSTF proof and adapter. This is what's doing these parts. Okay? And the other part that needs to be done in the proof is collecting all the information that comes from L1. I mean, I want to build a proof that, if you start with this state, or I need to collect, for example, the verification keys of the different chains, or I need to collect all the interactions with L1. So everything that happens to L1, and it's something that's going to be in the smart contract, in the call of the smart contract, I need to verify that this is correct according to the lock that's happening there. Okay? So we have like three pieces. We have like these three big proving parts, okay? And then all this needs to be aggregated, and at the end generating a proof. Okay? In order to do that, in this we are using it's what we call, it's a cryptographic accumulator. Okay? The idea of a cryptographic accumulator is kind of a hash function, but the idea is not, it's for sets. Okay? So the idea is that if you have two elements and you hash them, if you hash normally, it depends on the order. Okay? The idea is that in an accumulator, when you have two elements and you hash them, it doesn't matter if you switch or reverse them. Okay? So this is the idea of the cryptographic accumulator. Okay? And the cool thing of this structure is that in this, it allows you to have like many proofs, okay? And each proof can add things to the accumulator. It can add elements, which are hashes of something, and can subtract things from the element. Okay? And the full idea of building this proof is that we can divide the work of this proof in these different elements, and when we aggregate, at the end we are adding or subtracting this accumulator. So aggregating is just adding the accumulator. And at the end, the accumulator needs to be 0. So everything that's added needs to be subtracted. Or if you want everything that's proven, so when we assume something, we add something to the accumulator, and when we prove that assumption, then we subtract that in the accumulation. So at the end, everything that's assumed is proved. Okay? So if we see these different pieces, for example, when we are processing a blob, actually, what we are proving? Well, we are proving that the blob commitment, so the blob commitment that will come, I'm proof that this blob commitment is correct. Okay, so in this case, I'm subtracting from the proof there. What I'm assuming? I'm assuming that the starting roll-up state at the blobs, the starting or the roll-up states that happens at the roll-up are given ones. Well, I'm assuming this. Okay, and I'm proving that at the end of the roll-ups, this is going to be the state. But in order to do that, for example, I need to assume that the state transition functions of each of the states are correct. Okay? So if you see, for example, in the next, in the adapter, in the state transition functions, actually what here I'm proving it, so I'm subtracting them. So whatever I'm assuming when I'm parsing the blob, I'm assuming that this state transition function is correct. When I'm parsing when I'm verifying the state transition function of a given slice of a rollup, I'm proving, so I'm subtracting. So at the end, everything that's assumed, it's added, it's subtracted. So at the end, it needs to be 0. Okay. What else is here? Well, I'm assuming here, because this is they have different rollups. So here I'm assuming that a given rollup ID has a given proving key, so that the state transition function is so if I'm using this rollup, I'm assuming that this rollup is ID, and somebody needs to prove that this rollup ID has this exact verification key. Okay, and also here I'm assuming a lot of L1 transactions. So for everything that is an L1 transaction, I need to assume that actually these transactions are in the hash or are in the L1 transaction. Okay, and this is where the third part. Is the hash composing. I mean, this is just taking a lot of parameters and composing a hash. Okay, the hash of an L1. So here is all the information that's coming from L1. Okay, so in this case, for example, I'm taking all the blob commitments. So here, this proof actually is building a hash. So I'm taking all the blob commitments as I'm there. I'm putting them in. I'm building a hash. So with this, I guarantee that the blobs that I parsed in the blob provers are actually the ones that comes from the L1 that's telling me that are happen in the L1. This is how I link what's happening in L1, what happens in the proof. Okay? In the other side, I have all the starting blob rollup and the ending blob rollup. So the rollups is keeping all the rollups, and this is very much, so the starting blob rollups, this is, again, this comes from so this comes from the L1. So everything that's coming from L1, here I'm proving that in L1 is there is some state transition functions. Okay, and then in the blobs, I'm assuming. So this is what I'm assuming is what I'm starting. Here you see that when I have like different blobs that they connect each other. So the starting of a blob is added, and so the ending of one blob is added, so it's subtracted, and the starting of the next blob is added. So one cancel out each one. So at the end, you have in the accumulator only the starting point and the ending point. Okay, and this is what when I'm meeting the hash, this is what actually I'm putting in the hash, and this is what the information that I'm putting to the L1. Okay. Of course, here I'm hashing all the L1 interactions. All these L1 interactions needs to be in the call data when I'm submitting a blob. And this is going to be some structures that will be in the smart contract that are the ones that will be executed, in easy, so that when there is some rollup 2 that's calling a rollup 1, this code is executed in L1 and the other way around. So when something is happening in L1, that's calling to L2, well, all this interaction is recorded here so that everything is proved in the L2. So all these L1 interactions are also proven here, assume when I'm parsing the blob there. Okay? And finally, and this is important, is the verification key for each rollup. This is important and tricky, okay? Because verification key is variable, okay? So this is so I'm here. What I'm saying is I'm proving. So because this comes from the hash, or here I give the guarantee that the proving key has this verification key, okay? And in the blobs, so I'm assuming. So these are this rollup and the verification key. Important to mention here that this is these two ideas. We have the proof and the adapter, okay? And this is a trick, interesting trick that we are doing here, because we are proving something that's variable. So we are proving something, we are proving in advance, a rollup, so you need to have a prover that's proving something in advance according to some verification key, because a rollup that it will be added next year, it will have its own state transition function. So it will have a circuit with its own verification key, but we need to guarantee that this everything matches. Okay? So the idea here is that we do one recursion level. So the circuit will define its own state transition function, its own circuit. It will have its own verification key. This is what will be configured in the smart contract. Okay? And it's going to be one trusted smart contract, this adapter, that recursively will verify this other circuit according to the verification key, and will add to the accumulator of the full proof that will prove that this state transition function for this rollup is correct. Okay? And having this idea of this adapter that connects, so it's a double proof, I mean, that verifies, is what allows us to prove things that are not defined yet, because they are depending on the verification key. Of course, the circuit needs to follow some certain rules, but because it's just the verification key is very short. But that's the full idea of the easy. Okay. Once we have this, of course, we have the aggregation circuit. The aggregation circuit is just very much is proving. So here. So the aggregation circuit, it just takes two proofs of any kind, and it adds the accumulator, and it proves both sides, okay? And it generates a new proof, okay? And you can aggregate until there is just one single proof, and then there is a final, circuit that actually verifies this aggregation circuit plus the L1 hash proving, because in L1 you have only one hash, so you have a single one. And finally, we have the Plonk. So once we have this proof, we can convert it to a Plonk, so that's easily verifiable on chain. Okay? And here is a challenge. I mean, we need to build all these proofs. We need to build all these proofs really fast. I mean, ideally in a time block. Okay? So this structure, what allows is this model. And it's important to say that, for example, so when we are building a proof, at that point, we can start so when we're building a batch of transactions, we can start building the proof very much at the beginning, as we are adding, because we are creating a blob. I can start generating the proof for that blob. And creating a transaction, I can start generating all the state transition proofs for those transactions. And the cool thing of this is that aggregation, first, is super fast. So one aggregation circuit, it takes like about 80 milliseconds. And the second advantage is that this aggregation does not require any order, because the idea of this accumulator don't matter, the hash is exactly the same. So you can aggregate as you generate. So you generate two blobs, you can already aggregate them. Okay, you aggregate. So the idea is that the last 3 seconds, this is when we are doing the final part, or we are trying to reduce this, but the idea is that when we reach this point, that we stop building it, the remaining work for generating the proof needs to be minimal. Okay? So this needs to be in a pipelined way, and this is one of the important properties of this that that we are building. Currently, we are in 3 seconds. We believe that we can go even lower on there, but this is the real challenges that we are working for easy. Okay. As I mentioned before, currently in ZISC we are very much, so we just launched 1.0, so it's very much is about auditing, going deep, using AI for formally verifying, and there are some, just focusing, stabilizing this circuit, okay? And of course, in this building all the easy proving system, so that works as soon as possible. And here is a list of course, in this we have a list of other topics that are interesting, but are a second priority at this point. Okay, so but it's like, one is quite important, is moving. So I don't know if people know, but so there are some concerns about Poseidon functions. Actually, Poseidon 2 is somehow deprecated. People is going back to Poseidon 1. And it's possible that we may have some version for Blake, because cryptographers don't like these arithmetic functions, and for us is important. And the other things are things about optimizations. This BA, improvements, I mean, there is a lot other things that are interesting. Okay, so I want to finish here and absolutely open for questions.
Thank you very much. We have time for 2 questions for Jordi. Does anybody have a question they want to share? Yes, up here at the back. We can get a microphone up there. Give us a couple of minutes. You're a long way away.
Hi. I was just wondering, when you think of like synchronous composability and what it can do for rollups to kind of have like atomic kind of cross-chain interactions, do you think that kind of like paradigm could benefit mainnet itself? Like if you were trying to pursue some kind of like native sharding, could you kind of use this technology to actually use like create one big L1 essentially instead of relying on like separate L2s, if you know what I kind of mean?
They are not, I mean, yeah, these are 2 models, but this is like thinking that you can scale, I mean, you can do all the computations in the world in a single processor, okay? So definitely there is a lot of motivations for having L2s. Of course, one is to split the work, especially, for example, when an L2 has a lot of transactions that they touch only, the L2 only transactions, you can process much more of them. So first is the capacity, okay? But the other thing, and this is probably the one that I like more, is that this allows you to extend Ethereum. I mean, this idea is not only, so having many rollups is not about, it's not only about doing Ethereum bigger. It's extending the functionality of Ethereum. This allows you to build your own chain that maybe is specialized for voting, or maybe your chain is a private chain with your own rules. Martin before was talking about opinionated chains. And you can have a chain that, I mean, definitively you can decide to change the state root if there is a hack from an attacker. This is not acceptable from the Ethereum perspective, but may be perfectly acceptable, actually required in a specific rollup. So this is another motivation for having rollups. So the idea of having many chains, it goes beyond the scalability, which it does. It's more about extending, about building, expanding Ethereum, expanding the functionality of Ethereum, and making Ethereum more specialized for different applications, keeping the essence of Ethereum, which is the composability, so that one chain that maybe it's private, that belongs to some exchange company that has its own rules, it should be able to call maybe Arbitrum, or call some smart contract, some Uniswap calls. A chain, of course, will have the same rules. I mean, a chain will see that it's receiving a call and it's giving back a return. Okay? And when you are connecting to this chain, you will get a call and receive a return. And if you want like an oracle, okay? But you don't depend on that. Another important thing that I mentioned here is, and this is one of the designs that we are not mentioning very much, but this is important and easy. So in order to follow a chain, you don't need to follow all the other chains, even if you connect to those chains. Following a chain is just following L1, following those blobs, extracting the information, because in these things you get all the inputs and outputs that you get from your chain. So you can extract all this information, so you can rebuild your state of your chain, ignoring what's happening in the other chains. You are just getting what affects to your chain. So this allows to scalable, so having different chains, so not everybody have to synchronize everything. You are synchronizing your chain, the other is synchronizing your chain. Of course, maybe the composer, if they need to connect to chains, the composer probably will have to synchronize both chains. But it's just the composer, not an RPC client that's just providing some information. So it has a lot of advantages. So it's, and to be clear, I want Ethereum to scale as much as we can, and we need Ethereum to scale, and it's important that L1 scale as much as important. Among other things, because, for example, one of the limitations, if we are talking about one of the limitations of easy, is, for example, the data availability. We're talking about the blocks. We're putting a lot of information to the blobs. So we need high data availability in Ethereum. But one thing is the blobs, and the other thing is the Ethereum, each chain, okay? Haven't talked about validiums, okay? Validiums, again, it's perfectly possible for validiums to connect easy. The only thing is that the state, the difference is that in order to build the full state of a validium, you need some extra information that comes from other sources. This is perfectly valid because you are setting up you are setting the state, okay? The only thing is that in order to do calls to these chains, or the other way around, the composer needs to have access to this data. Okay, but because there is this independence, other chains that connect to this chain, they don't really need to have access to the full Validium chain. They need to have access to the interactions. That this is what's happening in the blobs.
Okay, thank you very much, Jordi. I don't think we have time for another question, but if anybody does have more questions from Jordi, I'm sure you'll be able to find them in the conference. Thank you very much. Next up, we have another easy-themed talk. I'm very proud to welcome Philipp Schomels to the stage. Philipp is the head of infrastructure at Gnosis. In most DappCons, he has the job of coming up and talking about glamorous topics like hard forks. Today, he has something even more exciting. He's here to talk about the technical implementation path for Gnosis Chain with the EASY framework.
Thank you, Ads. So hopefully you got some context about EASY, why we need it, and how it is technically possible now with Martin's and Jordi's talks. Here we're going to go through a more concrete example, like what happens if we take a live production chain today and make it an EASY chain. So we'll go through some context about EASY for those who weren't there for Martin's talk. Context about Gnosis chain, and then how EASY works under the hood, as well as how it will look like in practice for Gnosis chain. So let's start with the context. The whole point of EASY is to have synchronous composability between multiple chains. In the simple example here, I have just a L1 and L2, so Ethereum, for example, Gnosis chain. Of course, currently, if you want to interact with a different chain, you have to bridge, and that takes some time, right? It can take up to 7 days, for example, for fraud-proof rollups. With EASY, all of this becomes one single transaction. So you interact, you read and write on Ethereum and on Gnosis chain at the same time. One transaction, one block, fully atomic. What is needed for EASY is first and foremost that you need to be able to reorg with Ethereum. So when, you cannot use state that is on the L1 on your own chain if it was removed, right? If you do a trade like you swap some tokens on your L2, if the L1 then reorgs and you don't have the other side of the trade, that obviously does not work, so you also have to reorg at the same time. Then, that's necessary for synchronous composability in any way, but for EASY, it's also best if you integrate with the EASY contracts, have a composer, and and use cross-chain proxies. We'll go over all of those one by one, and the rest of the elements, so whether you are producing blocks in a based way, sequenced, use proofs, you have to use proofs, but whether they are ZK or something else like a multisig, data availability, VM, all of this is up to the chain to choose. Now, some context about Gnosis chain. It's a network that's been live since 2018. Hopefully, you all know about it now, but maybe you don't. It's basically Ethereum just with a few tiny changes, right? So we have faster block times, 5 seconds instead of 12, sorry. We have faster epochs, so finality is faster as well. And the staking token is GNO, which is an ERC20 token rather than the native token. But basically, it's the same architecture, same client, same beacon chain, whatnot. Of course, it is a live network, so it has apps, infrastructure, and for example, it runs Gnosis Pay and Circles. Now, hopefully the opportunity for Gnosis Chain should be clear, right? We want security composability with DL1, at least to begin with, and potentially with other L2s as well. This would give access to liquidity from DL1 directly, so you don't have to have liquidity, for example, on L2, or less so at least. There's no longer any bridging, so it's instant, and there would be a huge first mover advantage for Gnosis Chain, because no other chain currently does this. When I'm talking about Ethereum liquidity, it also allows you to do, for example, liquidations in 1 second transaction with funds that come from DL1, go to bridge in the same transaction to L2, so to Gnosis Chain, liquidate there, and then bridge back if you want to. So it enables a lot of new options. So how does Easy work under the hood? I'll start with the first component, which is the composer. And essentially what it does is simulate transactions across multiple chains at the same time. Again, here's a more basic example with just 2 chains, so Ethereum and Gnosis Chain, for example. It has the state of both chains. Then it gets transactions L1 and L2 from a mempool. Ideally, it's private, and I'll explain why later. And then it basically simulates all those transactions on both chains at the same time and creates one block at the same time for the L2 and, well, the transactions needed in the L1. So one question is, how does the composer know that a transaction actually crosses the chain boundary? So how do you know that if you do a transaction on Ethereum, at some point you're going to Gnosis Chain? This is where we introduce cross-chain proxies. So here, for example, we have a contract on Gnosis Chain that is called B, very original, and it has a proxy representation called B star on Ethereum. So basically, if you call B star on Ethereum, the composer knows this is the contract B on Gnosis Chain. This is all written in the proxy, basically. The proxy here can be called by any caller. It can be an EOA, it can be a contract, it can be whatever. And those cross-chain proxies, they can be deployed deterministically, permissionlessly, and the objective is that they can be basically be used in the current ecosystem. So you don't have to update apps. So technically, it would be possible to use, for example, the 12 bytes that are empty in an EVM address to signify what chain it is on, for example, like the contract is targeting. But we are not doing this because we don't want to have to update all the dApps, basically. Now, this is a rough example. I think Jordi had one that was a bit more complex, but let's just quickly show how it works. So imagine you're on Ethereum, and then you do a transaction on a contract called A. It can do whatever it wants on this contract, so that's it calls whatever, but at some point it calls contract B star, which again is a proxy representation of contract B on Gnosis Chain. Now in this example here, it just calls b.increment or b star.increment on Ethereum. And there on Gnosis Chain, again, you can do whatever you want. So nested calls, modify state, of course. The state will also get committed, obviously, because then if not, it doesn't work. And then at some point, the contract B returns some value. I mean, it can also just return nothing, but in this case, it returns 42. At that point, the composer goes back to Ethereum, continues execution on Ethereum, and then the contract A can again do whatever it wants with that value. So there's no callbacks, no bridges, nothing, just one transaction, and that's it. Now, obviously, this does not really happen that way on Ethereum, right? You cannot just do a transaction and then stop execution on Ethereum. We are not running Vitalik's masternode, unfortunately. So how this works is that we have execution tables. So execution tables essentially are a log of everything that happens on both chains. So they can be, just to be simple here, they can be, for example, a call. So you call a different chain. They can be a return or a revert. Those are, of course, all part of the proofs. So you cannot modify an execution table and then still expect the call to go through. Then that block becomes invalid. So these are all created, the execution tables, while the composer simulates the transactions. And if we go back here to the previous example, you can see we have here, so one call, one return. So that's one execution table on Gnosis Chain that is an incoming call, and one on Ethereum that is, well, a return. Of course, I mean here, Ethereum, Gnosis Chain, it works with DL1 and any other L2. It's the same principle. So in that previous example, we end up with two execution tables. So in Ethereum, just the fact that we called in this specific context or in this state by this user with this call data, just to keep it simple here, we call b star.increments, and we get the answer 42, and then on Gnosis chain, a star, which is a proxy representation of a but on Gnosis chain. This is called, so we have an inbound call, so we have to execute it, modify the state on Gnosis chain, and that's also an execution table. Now, this was just the first part of the magic. Of course, that by itself is still not enough. So we have to post this on chain now somehow. And the whole idea is that basically we are front-running the user's transaction. So again, let's go back to this example here. So A does a transaction, calls B star. If we do it without anything, B star obviously does not know that the result will be 42 if you call B star.increment. So what we're doing is that before this transaction even happens, we are inserting something in the easy contracts that says, if in this specific context, so this specific state, whatnot, A calls B star.increment, then the answer would be 42. So we front run this in our post and verify batch, which also includes blobs, for example. I mean, it includes the call data, state roots, whatever the L2 needs, and anchors to the L1, it includes that. But in addition to that, it includes the execution tables. So basically, again, we front run. So B star can call the easy contracts to check what would the value be. And then after this, we include the L1 transactions. So in this case here, the user transaction that calls A, which ultimately calls B star.increment. This we do with just an eats and bundle, so basic MEV bundle that will get executed by L1 builder. Of course, this is only valid for one specific state or one specific block. And if the batch doesn't get included, for example, if we didn't pay enough gas or whatnot to be accepted on L1, then we have to, I mean, it all reverts, and we cannot actually do the synchronous transaction. So again, quick summary, what makes an easy chain? You need to reorg with Ethereum. You also need to prove it, so that can be with ZK or a multisig, whatever. Then you need to use the easy contracts, have a composer, use cross-chain proxies, and the rest, again, is free to use, or free for the chain to decide. Now, we already have this. I think Martin Jordi touched on this already. But basically, Jordi wrote an ETH research post in February. By April, we had a prototype of the composer that could do nested calls via multiple chains, multiple nested calls. So we can prove that we have instant deposits, calls with returns, even cross-chain flash loans or whatever. We tried this with nested calls that are 5 levels deep. But this is just a limit we set for ourselves. Technically, if you can pay for the gas, you can do as many as you want. Now, I mentioned that you can basically, like a chain, can decide many of the aspects to integrate with Easy. Now I'm going to go over what we think we should do for Gnosis chain. So this is not quite final yet, but we are working on those assumptions at least. And what we want to do for Gnosis chain is to have a sequenced chain with 2-second block times. We will prove the blocks with a multisig, so not fully ZK proven yet, and post all the state roots, call data, and whatnot in Ethereum blobs. Now, you might question those choices, and I would totally understand that, but I'll try to convince you that this is the best option, at least for now. So why not ZK? Well, ZK teams, like for example Jordi's with Zisk, are doing a lot of great work, but we believe that it's still a bit too early for Gnosis chain. First reason being that we want to have at least three different client implementations, but also ZK provers. And they need to be, of course, able to prove everything in real time. The second reason is that we believe that it's still a tiny bit too slow right now for our needs, and I'll actually get back to that a bit later. Why do we want a sequenced chain? So basically now we have this beacon chain with a lot of validators, but Gasper, so the algorithm behind the beacon chain, was not really made for fast block times, for example. So we want 2-second block times, and that's just very complicated to do in a fully decentralized manner where you have to attest all blocks and whatnot. The second reason is that composing is a heavy operation, right? Right now, you build blocks on Gnosis chain, you just run Gnosis chain. If you want to do this with synchronous blocks, you need to run Gnosis chain, but also Ethereum, and potentially many other L2s with which you want to compose. So it's a very heavy process. We could use builders for that, but anyways, later down the road, it will just make things more complicated when we want to add new chains, for example. Also, again, we need to reorg when Ethereum reorgs, and we cannot reorg if Ethereum didn't, at least if we rely on that state. And Gasper, again, was not made for this. It was made to finalize on its own, not to finalize based on a different chain. And it also cannot guarantee that a current block that was mined or created will not reorg when this underlying L1 block did not reorg. So basically, just Gasper wasn't made for it. It doesn't really make sense to reinvent the wheel and to modify all the consensus layer clients. So we believe that sequenced is the way to go. Now, you might ask, what happens to the Gnosis validators? That's a very good question. Honest answer is, it's not quite clear yet. But ultimately, most likely, the set will have to get deprecated. How that happens, again, not clear. But anyways, all of this will go through the DAO with a GIP. So technically speaking, well, a bit more technically, without going into too many details, what does that look like? We have a chain that produces 6 blocks per Ethereum block, of course. One of these every time will be able to be synchronous, so have synchronous transactions, basically. All the other ones will be pure L2, so we continue building the chain without synchronous transactions. And all of these blocks will be signed by the sequencer. It's going to be permission to begin with. It's just, again, a design choice to move fast, let's say. Of course, the sync blocks don't necessarily have to be synced. So if there is no synchronous transactions, we can just continue building normal pure L2 blocks. And if that happens for some period of time, we would still, let's say every couple of minutes, anchor our L2 state to the L1 to post the state routes, post the call data, and everything you might need to follow the chain. For a composer, we actually want to start with a simpler version. So we call this, for now, let's say Composer v1. Well, not the official name, but whatever. And what this will allow is just one incoming call from the L1, so from Ethereum. There it can do whatever it wants. Then one call to Gnosis chain where, again, it can do inside of Gnosis chain one of it once. And then one return call where it can resume execution again. We believe that this actually gives you, let's say, 70 to 80% of the capabilities, right? As mentioned before, you can swap tokens on L1, bridge them to Gnosis chain, liquidate someone there, bridge all of this back, all in one single atomic transaction. Of course, the objective longer term or even midterm is to have full composability, full nested composability. So we can go from L1 to L2 how many times you want, however many times you want in one single transaction. So follower nodes, so basically for those running nodes currently, a follower node is what I'm calling nodes that can sync the network but not create blocks. They will work a bit differently now as well, so they will get blocks from the sequencer every 2 seconds, and then also validate every time that the batch is posted on the L1, be it a synchronous block or an anchor. They will validate that the state they received from the sequencer is identical from what they see on the L1. But of course, you can still run a node, you can still have your own private RPC, run everything locally, do simulations, all of this stays the same. For the user, ideally, this is simply a client update, basically. So you have your REST node, let's say, you just update it to a new version, and then there you go, you participate in the Gnosis chain hard fork, everything works as before. The way we are validating the blocks is that the current bridge validators that are, well, basically validating transactions and bridging them over, right? This is a validator set currently a multi-sig 4 of 7 for Gnosis chain. They could potentially become chain validators. So they will run 3 different kind of implementations. They will validate locally that a block created by the sequencer and the composer are valid. Then they will attest to it, and we post the aggregation of these attestations with the post and verify badge on DL1. So what this gives us is a chain, well, that is very much like Gnosis chain, so the state is the same, but we rip out the consensus layer and replace it with something else. Of course, we would lose some functionality that the beacon chain provides to us, for example, blobs. But yeah, so the transaction times will go lower, so block times from 5 seconds to 2 seconds. We have to reorg with Ethereum, as mentioned plenty of times now, and the finality will go up slightly, but that also means that we'll inherit from Ethereum when they decide to go with faster finality like 3SF or whatever DEF is working on currently. Of course, all of this also gives us synchronous and atomic composability, which is the whole point of Easy. So I'll be honest, there are still a few issues that are not necessarily fully resolved yet, and 2 of them are linked to timing. So for example, inclusion time in DL1 is not necessarily known very quickly. So if you do a sync block here, so we have blocks every 2 seconds, right? If you only know after more than 2 seconds, let's say 3 seconds, that a block actually, like that your bundle was accepted in the layer 1, then it's not quite clear what block you have to build your next one on. So let's say this block, do we have to build it on the sync block if it gets into the chain, or do we have to build it on the previous block? We don't know. Martin alluded to something where we could basically do different variations of those blocks and then take the one that is appropriate, but it's just a bit more complex. The other issue is linked to proving, as I was talking about earlier. So for proving, you need a bit of time after the proof. Hopefully that hasn't changed since last time. Wasn't able to fully listen to Jordi's talk, but presumably he talked about this. And so basically, if you have transactions here, you still need to build 2 blocks to post it on DL1. If you need 3-4 seconds at the end of a block to prove it, of course you cannot prove the last 2 blocks, right? Because you just don't have time. That means that those 2 last blocks will always be empty. So the T plus 10 and the next sync block, they will always be empty because you don't have time to create them and prove them. A solution for this would be potentially to build those blocks earlier, so at T plus 8, so 4 seconds before the next block. You could actually build the normal Pure2 block and then 2 more that you then have time to prove entirely. But they would then rely on slightly stale data, right? Because you don't get the transactions that happen here, you are not able to build a block that includes them. And of course, synchronous blocks, they will always include transactions that are at least 4 seconds old and up to 16 seconds old, if that makes sense. This, to be clear, is not an issue with a multisig prover, which is our preferred solution at the moment. But if we were to go fully ZK proven, this would be an issue. Now, I want to close with a bit of a timeline. I'll be honest, it's also a bit optimistic, at least very aggressive. So as mentioned, there was this Jordi post on it research, and we have a functioning prototype now for the composer, fully nested and whatnot, but also for the sequenced chain. And our plan is to hot fork Shadows, our testnet, by end of September. And then hopefully Ethereum, mainnet, so Gnosis chain, by end of December. Of course, once all of this is done, hopefully by end of December, we'll work on full nested composability as well as ZK proving, which are still obviously our objective, right? We want to do this the right way. We just want to do it a bit earlier, so a less perfect version, but earlier, basically. And yeah, that's it for me. So here are a few links if you want to follow development on GitHub and follow news on Twitter. I hope this helped you kind of get a clearer picture of what Easy is and how we could implement it with Gnosis Chain.
Thank you very much. We have time for some questions. Who has over here? Can we get a mic over here? Thank you.
Thank you. So I was wondering, in this process, as a user, how much transparency do I have on each transaction, at sort of where in the process is my transaction? And I guess in a reverse manner, to what extent is that information public, i.e., how do I avoid front runners if I were to do a transaction that invites front running?
Okay, I'm not sure I fully get the question, to be honest. As a user, this is basically transparent. So you just send your transaction ideally to a private mempool, because if you don't, like if you just do a L1 transaction that has a cross-chain call, and you send it to the public mempool, then a normal Ethereum validator can just pick it up, mine it, and then, like in the, well, it's a few slides back, but in the bstar.increment example, if we get to there, right? Here, bstar.increments, if we don't front run it with the composer, but it's not really front running, like we're not doing anything bad. We just have to seed the state on the L1. But if this is done through the public mempool and a validator picks up the transaction, it gets mined, and then bstar.increment will just revert because you don't know what the value actually is. Yeah, so but except for that, it's transparent. You just post your transaction to a private mempool. The composer will do all the simulations, and then it will submit a block to the L1. So there's no steps. This all happens like behind the scenes as if it were a normal transaction. I don't know if that kind of answered your question.
It's more if that was a large transaction and you have front runner confidence in the left market, they would still receive.
Yes, I mean, yeah.
Any more questions for Philip? Okay, no more questions? We have, I think, just over 5 minutes before the next and final easy-themed session. So we'll ask for your patience while we set the stage. We will be back with you as soon as possible. By no means least, we have our final easy theme session today. Now, I'm a little bit nervous because it's not every day you get to introduce one of your heroes. I can see by how full the room is that you're excited also. Dr. Friederike Ernst is one of the founders of Gnosis and a passionate champion for the Ethereum economic zone. She is joined today by someone else you may know, Vitalik. We'll be unpacking what Ethereum might mean with easy.
Cool, fantastic, Vitalik. Thank you for being here today.
Yeah.
This is the last talk in an easy themed block. So kind of,
Okay.
I'll ask you for your take on.
So the next talk will be in a hard block.
Yeah, actually, so kind of medium first and then hard. So kind of
I see, okay.
We're still cutting it on the easy side.
I see, so we're going to do like a tutorial of like circle starks after this.
Yeah, absolutely.
Okay.
So guys, I leave some time for questions from you in the end. So kind of if you have questions already, kind of like maybe think on kind of like what you want to ask. So we already heard Martin's and Jody's and Philip's take of the easy. So kind of the term Ethereum economic zone obviously kind of does a lot of the heavy lifting here. But kind of what makes the easy in your head? Is it primarily kind of like an economic thing in kind of like a single market kind of sense, or is it kind of like an economic operating system? What's your take?
Yeah, I mean, I think for me the core, right, is basically it's an effort to rethink, what layer 2s are in a way that kind of both gets a lot more of the benefits and at the same time less of the drawbacks of all of the approaches that we've tried so far, right? And to make something which is much more integrated into Ethereum, and so it's not just basically a separate EVM chain where like it can be difficult to like see like the connection beyond the branding level, right? And it's like actually very deeply integrated in a way that's like very visible to users and developers, and at the same time to like actually get benefits from that integration, right? And like to me, the benefit of benefits of being in L2 has always been, the tight integration with the Ethereum market and the Ethereum user base, and also the fact that you don't have to be responsible for a lot of your own infrastructure, right? Like you don't have to be responsible for having your own set of nodes to the same level. I mean, if you have a based rollup, you don't even need your own nodes. You can, basically your infrastructure load on every level is just much lighter, right? Potentially, if you do it right, you don't even need to convince users to create new accounts. That's also another thing we should work on, right? And the possibility of having this like synchronous composability between L2s and like having much better forms of bridging on top of that with better developer experience, and also having ZK proofs securely enforcing that, like it really does accomplish all of those goals, right? And so you get you get more integration, and you get kind of more power at the same time, and like at lower cost, right? So it's something that should be a win-win for everyone.
Well, that fits in super nicely with what Martin said. He said it extends basically what the presence is, so kind of what the present is for Ethereum and kind of like all the zones in the easy. Essentially, they kind of start living in the same now. And Jody said, kind of by having differently natured zones, you can actually extend Ethereum rather than kind of just adding more block space. You can actually see specific you can see use case specific chains or chains that are specific in some other way. So kind of if you kind of think maybe 5 or 10 years in the future, if you sort everything that anchors to Ethereum into a few buckets, what are they?
I mean, I think the projects that we've seen so far, right, that like extend Ethereum in an interesting way that's not just like EVM with more TPS. One of them is privacy, right? So like IntMax and Aztec are very good examples there. And I know there's more and more projects trying to do this. I mean, I actually even think of things like Tornado Cash and Railgun and privacy pools as being L2s. Like they're L2s of privacy instead of L2s of scalability, but I also think of them as L2s. I mean, with Railgun, you can even do internal transactions. Those are, I think, great and underrated by a lot of people. Then the second is like very high TPS for specialized use cases, right? So Lighter would be a good example there. And I think in general, like having a mass scale prediction market or other type of like DeFi primitive. But I mean, I think ultimately you can sort of define every DeFi primitive as a special case of prediction markets in some sense. Then like having that run on an EEZ rollup, I think feels ideal. Then if you want to kind of start going further, right, then, and I think like privacy is a dimension we have to keep improving on, right, and I expect, I mean, as Aztec has already started doing, right, and especially as Ethereum L1 continues improving on privacy natively, like privacy-focused L2s connecting into Ethereum will have to get into private programmability. And we're seeing that. I hope to see more of that. I hope we'll also keep getting better cryptography that helps us keep getting even more of that. Then I think there's like interesting directions that are underrated, and having an integrated Oracle I think is interesting. Like, you know, the whole Oracle space I still think is you know, one of the sort of skeletons in the closet of Ethereum, right? Like if you compare the level of rigor that people like L2Beat have brought to the like L2 space with things like stage 1 and stage 2 and just all of the like efforts that like Optimism and Arbitrum and Tycho and others have spent like actually getting there. And like if you compare that level of security to like what happens inside of many oracles, it's like night and day, right? And you know, like one of the things I always keep saying is that there's no point in giving reinforced steel doors to your house if the windows are like made of glass that breaks after one hammer hits it, right? And so like I think we might even be in that kind of situation, right? And so I've always been thinking like actually like maybe the thing that's even higher priority than a push to stage 2 is improving oracles. And you know, the push to stage 2 will happen naturally, especially with native rollups and ZK EVM sort of giving us that for free. And with like integrating an oracle into an L2, like I think, you know, oracles can't be perfectly economically secure, but you know, you want the security base to be as big and as diverse as possible. So I think that approach is interesting. Then what other things for L2s? I mean, just like there's the whole different kind of L2, which is sort of ultra specializing for like enterprise type use cases, right? It's like basically you approach the problem from the other end. You, instead of saying, we have an Ethereum chain, how do we make it more scalable and user friendly? You start from the other end and you say like, here is some enterprise thing that's serving many millions of people and like helping a lot of economic activity happen, but it's like totally trust dependent and centralized. And like, how do you add proofs to that so that you give users better guarantees? And that could apply to supply chain things, it could apply to finance, it could apply to medicine, it could apply to voting systems, right? And you know, like Orin's interfold work, I think, is one of those great examples of that. So, no, I think you know, there's a lot of different directions from which you can tackle this problem.
Do you think about chains that are run by nation states or so, kind of, because I mean obviously nation states are typically extremely hesitant to kind of put any kind of infrastructure onto Ethereum. Do you kind of see Ethereum becoming kind of the ultimate settlement layer even between nations that don't speak anymore, as we kind of increasingly see?
Yeah, I mean, it can happen, right? Like, so one of the patterns that we've seen historically is that there are these government blockchain projects that first try to make their own consortium chain, and like they go all their way out in the direction of like satisfying the more conservative people, and then that just never ends up actually getting any interesting properties, and so 4 years later everyone forgets about it and the thing spins down, and then another 4 years later the same country just quietly spins up a thing where they just like dump friggin' NFTs on mainnet, right? And like it's actually more useful. So I think it's use case dependent, right? I think you don't want to sort of attach like too many of these, like philosophical connotations to the concept of like being on L1 or the concept of like being on L2, right? It's kind of like attaching, like too many philosophical connotations to like being in a house or being in an apartment building, right? It's like you want to kind of view it as a technical matter of like what are things that you want to be close to, what are things that you want to have very easy ability to interoperate with, what are forms of scalability that you want to have, what are forms of privacy that you want to have. I think sometimes, something like easy is a good solution. Sometimes, just dumping a friggin' NFT on mainnet is a solution. Sometimes dumping a friggin' ERC20 on mainnet and then letting that bridge into easy is a solution, right? So, you want to be open to all of those.
Yeah, absolutely. So kind of if you look at Ethereum and kind of like how it's developed over the last couple of years, Ethereum made a very explicit choice that most or maybe all other chains didn't. Kind of like it put censorship resistance above everything else. So kind of namely above speed, above cost, above recourse if anything goes wrong, right? So if kind of once kind of the code's committed, it just runs. So that's a choice, and that's a choice with real losers to some extent, because most users, they don't wake up and say, oh, I want to be on the most neutral chain possible. Or they kind of, they want their payment to clear and they want their money back if they were scammed or if something breaks, right? So should it be the base layer's job to serve users at all? Or do you think kind of it should be kind of more of a neutral ground that other networks then build user experiences on that kind of users are happy with?
It's a difficult trade-off, right?
Yeah.
I think, because there's a lot of attraction to kind of going all the way and basically saying like, well, the base layer does the minimum possible to ensure things like trust and security, and then everything else happens on top and people can choose. One of the challenges is that often if the base layer provides too little, then like you still get certain types of capture that happen at higher levels, right? And if you don't care about interoperability explicitly, for example, then interoperability gets captured by centralized providers, and then like you get applications that basically don't think of like themselves as serving Ethereum users, but think of themselves as like creating identities for users fully inside of their application in a way that kind of really maximizes lock-in, doesn't really create the benefits of a user's account being able to be part of multiple applications at the same time. And so there is a balance there, right? Where if you don't try to like make sure that things like interoperability, censorship resistance, just like stronger pressures toward having a proper competitive market actually exist at the user layer, then effectively what you get is like you get these walled garden monopolies just to sort of wrap around the base layer and like use the base layer a little bit, basically just so they can virtue signal and say that, hey, we're on Ethereum, but then like actually the thing is not bringing freedom to people. I actually, again, like view Easy as a quite helpful effort in that regard, because it's like really doing that work to make these higher levels of interoperability available, not just kind of in theory, but like actually creating standards so that if L2s get built inside of it, that interoperability exists between them by default.
Cool. Let me ask one last question, and then I'll hand it out to you guys. So if I say I had an extremely specific crystal ball, and kind of it would allow me the answer of kind of to one question exactly, and that's kind of whether a specific kind of network exists in the Ethereum economic zone in 2035. What network would you ask for to kind of see whether it's there to kind of gauge the success?
I mean, I guess one natural use case is like to have at least two, like high performance, high TPS DeFi type things, which could be lighter style, could be a prediction market. I mean, could even be also something that provides privacy, and then like actually see the like easy deposit, easy withdraw, and like cross composability happening between them, and like actually see the value provided by that. So that would be one answer. I think another answer is like it would be interesting also to kind of see some of these in like more non-financial L2s, and like the possibilities for having like say DAOs that kind of integrate into that and like use one for their governance, use another one for like managing their internal assets and so on.
Cool. Thank you. I see we have 9 more minutes. I think that should be time enough for at least 3 questions. Do we have questions from the audience? Yes, here in the first row. Do we have a mic somewhere? Okay. Ads, do you have a mic? Or does someone have a mic?
I have a mic.
You have the mic. Okay. There's a mic coming. Maybe you can ask your questions, and a question I'll just repeat it for you. Okay, yeah, absolutely. Oh, and there it is.
So thanks for the talk, Vitalik and Friederike. So I wanted to address something that Vitalik mentioned at the start of his talk, his spiel, saying that a lot of I think one of the benefits of NL2 is that a lot of the responsibility can be taken off your shoulders. And I think what I just wanted to bring up what steps could be taken for something to fill in that void, because I think part of the purpose of the developer experience is that is giving this responsibility or vesting this sense of responsibility for the users, and I think that that's one of the core benefits of what makes Ethereum what it is in the first place. So, do you reckon that there could be steps to be able to address this?
Sorry, steps to address what?
Like the responsibility aspect that developer experience could bring.
So like in the sense of like easy or like other work, like reducing the level of load that L2s have?
Yeah, exactly.
Yeah, I mean, I think like that's just exactly the thing that like both Easy and a lot of other efforts are doing, right? Like if you look at the work that a lot of them have to do right now, like a big part of the load is building the proof system, right? And the proof system like that is, in the long term, that can be replaced by the native rollup precompile, right? And that's like a huge amount of work, and it's like work that has caused, years of pain for a lot of these big rollup teams, and it's basically gone, right? Another example is interoperability, right? So right now there's been a lot of effort spent on making interoperability systems with better trust properties, and also a lot of more well-funded work on making interoperability systems with worse trust properties. And if you kind of make that native, then like again, that's a much bigger improvement. Like potentially, you don't even need intent-based bridging in a lot of cases, because like the kind of interoperability here we're talking about is like interoperability as fast as L1. And another one that like I actually think this space has not been thinking about enough that it could is on the account side. Like I generally believe that like we should get away from the model of a user having an account on every chain. I think your account should just be on Ethereum, and like basically every transaction should sort of be use a start and like synchronously like prove from your Ethereum accounts that you're allowed to spend the assets that you have. And so, like for all of those kinds of steps, right? Like they can be done by kind of a relatively smaller group, and like they all reduce the amount of work that needs to be done at like every other layer in the ecosystem.
Hey, are there any lessons to be drawn from other attempts to create similar style shared security, interoperability, economic zone type things? I'm thinking specifically of Cosmos.
Yeah, it's a good question. I mean, I think it's like it's definitely difficult to kind of compare one-to-one, right? Because I think EEZ is just so completely dependent on these new waves of technology that like literally the entire wave of previous attempts to do things did not have at all, right? Like Cosmos, did not really have access to like synchronous kind of ZK proofs of everything and like strong guarantees that it's formally verified. Also, the other big thing to learn from is, of course, like Ethereum's own experience trying to kind of herd the cats and like do things like OIF, do things like EIL, even some of these kind of like Optimism and Arbitrum internal ecosystems. And so far to me, kind of one of the big learnings of them is basically that they just did not kind of create enough of the type of interoperability that actually mattered, right? And like it still basically ended up being pretty close to just having separate chains, right? And the problem is, like, when you have separate chains, like, they still feel like separate ecosystems, they grow like separate ecosystems, and like you have bridging, but then like bridging is always this kind of fairly awkward second-class thing. So it's yes, like I feel like it's like basically our ability to surpass that is like pretty much entirely based on these technological things that were sort of not feasible. At least they were like theoretically possible as like a long-term North Star item, but they were not really feasible 5 years ago. Not really feasible 5 years.
Hi.
Yeah.
Here. Hello?
Yes?
It's here. Here,
Where?
speaking.
Okay.
Okay. Hi. So if we think about EEZ like as a system that harmonizes layer 2 states with Ethereum, how can we make sure also that, let's say, the off-chain rules and the off-chain experience is synchronous as well, and provide an experience end-to-end which is synchronous and interoperable and like a heaven?
What does it mean for the off-chain experience to be synchronous?
Like a service that has a lot of rules to check, and how do they fit into the synchronous experience also with the on-chain environment. Maybe oracles and smart contract accounts have a play also here in facilitating the process.
Yeah, and this feels like a very application by application thing, right? I guess, are we talking about like off-chain user experience, like user experience of activity that's still on chain, or are we talking about like some hybrid between accessing the chain and like doing something with TradFi or some other server? The first one. Yeah, and I think there's definitely a lot of like access layer issues that need to be solved. I mean, one of the best things that's happened over the last couple of years is that we have transaction simulations, and we can go further, right? And there's EIPs that are kind of building on top of frames that basically make it possible to have transactions that only execute if like every frame, like basically the full execution is exactly equal to the simulation results that you pre-commit to. So that's a big improvement. There are also improvements in like how you access the chain, how you get like state, how you send transactions, and like improving the privacy, improving the censorship resistance and scale and security of that. So we've been thinking about that quite a lot. Though I think within the EF, it's kind of primarily in an L1 context, though a lot of that is kind of pretty extensible to other areas. Then, what other things? And then there's like other situations where I think, synchronous is something that you think you want, but the thing that you actually want is just faster. And often there's ways to make higher speed possible without it actually being explicitly synchronous, and that can happen both at the chain level and off-chain. And there's a lot of areas that we're trying to improve on in both of those too.
Well, we have time for one more, I think.
Hi, good stuff. Quick question. So you mentioned bridges and second class in one sentence. And you also mentioned just right now that you just sometimes need faster. So bridges is in EEZ, I guess, mainly L1, L2. So what about the L1 to maybe other L1s? Do you have any thing on the roadmap further out in the near, how you would potentially integrate Ethereum with other L1s, for want of a better name?
Yeah, I mean, you can, like with zk and ARCs, you can do that in very simpler ways. You just have to deal with more trust assumptions.
Cool, that was super quick, so one more.
I mean, the trust assumption, right, is basically that like you have two different chains that have two separate consensus mechanisms, right, and like they can revert separately. And so if you move coins from one to the other and then one reverts without the other, you might get like coins on both sides or coins on neither side, right? And with L2s, like to have atomicity, you need this property that basically the L2 is kind of, like the L2's fork choice is sort of subordinate to Ethereum's fork choice. And so if Ethereum reverts, the L2 reverts. If Ethereum doesn't revert, the L2 doesn't revert. And like all the atomicity properties are dependent on that. And so with L1s, you don't have that. And so like, yeah, you just have that extra trust assumption. And like you either accept it or you find some insurer who's willing to put up collateral for it.
In my view, this is one of the most important innovations in the Ethereum ecosystem for a long time. You solve UX problems, you bring back synchronous composability, you solve bridging. What is the idea of the Ethereum Foundation to step behind this movement? So if this works, this could be a huge step forward. What do you plan, Vitalik?
I mean, Ethereum Foundation's got its hands full doing a lot of things, right? We have a big roadmap. We're trying to make the Ethereum protocol quantum safe, trying to do a lot of things. Also trying to figure out how to do native rollups. And so I think this is exactly like one of those areas where it's kind of very helpful that the EEZ is also stepping up to do all of the kind of parts that are sort of outside of Ethereum proper. And I think it's like there's a lot of things that need to happen on both ends for this to work.
And it is co-funded by the Ethereum Foundation, so kind of they are stepping up. Cool. Thank you, guys. Thank you, Vitalik, for coming. It was a pleasure.
Yeah.
Okay, there will be a short break of maybe 10, 15 minutes before the afternoon's talks will continue. Thank you, everyone.
She has done all of the proof concept of the development of that, and she will be sharing with us the hurdles, the challenges, the successes of what it is to build and to bring macro data on-chain. Well, let's welcome her with an applause first.
Well, hello everybody. Thank you for staying behind. It's always a tough time following Vitalik, but I do have a couple of words for him in a second. I'm Brenda, I'm the CEO of Teller, and Teller is the only oracle that was designed to be decentralized from the beginning. We launched in 2019. We were a fair launch. From the beginning, reporters were required to stake. They could be disputed on-chain, and anybody could request any type of information as long as they tipped on-chain. So yes, on his last talk, if you guys didn't catch it, he said that one of the most important things that we could be doing in the space is actually improving oracles. I couldn't agree more, and I would love for you, Vitalik, if you ever see this talk, to actually come out and talk to me about it and actually call out why and what oracles have been doing wrong, or centralized oracles, make a distinction between centralized oracles, decentralized oracles, and help us grow. So with that, a very direct message, I'm going to move on to what I'm actually here to talk about. So before crypto, I was an economist with the Bureau of Labor Statistics, and the Bureau of Labor Statistics puts out a lot of the major statistics for the US government. Today I'm going to talk about bridging macroeconomic data on-chain and why that has been so difficult. The oracle problem for market prices and macroeconomic statistics is very different. So market prices in general, you can observe the majority of the markets, you can observe them, right? In general, you can find where the majority of the volume is happening, and you can come up with some price discovery that is observable. When you're talking about macroeconomic statistics, it's a lot harder because you're talking about a lot of different aspects of the economy, and it's very, very hard to observe. It's very hard to observe for anybody. Also, they have two different manipulation surfaces. For market prices, you have the markets, so that is observable. For macroeconomic statistics, it's a lot more subtle, and it can be within their methodology, and it can also be just political capture or coercion, because politicians fund the very statistical agencies that produce them. And people don't always make the connection between the CPI or inflation and how it directly affects them. The CPI is used for so many things by the government, from adjusting pensions and payments that go to the public, like like different things, like in the U.S., like for safety networks, they'll be changed based on inflation, so that could mean that the government has to give out more money in assistance payments. Also, wage escalation, so most government employees will have their pay increase based on inflation at the end of each year. Also, they use it to inform their monetary policy, and the IMF actually uses inflation, or the inflation in any country, as part of their risk assessment. The higher risk you have, the more conditions the IMF might put in your country when they lend you money, or when they lend them money. So with that said, people don't always understand how politicized this number is. From the inception of the CPI in the US in the 1890s, it was commissioned because Republicans and Democrats were arguing about who was right about the McKinley tariffs. And then it took 90 years for them to actually create, or for them to actually include Blacks and Hispanic families into the survey, so they didn't have the entire population. And then in 1999, the Boston Commission report had all of these changes to the CPI methodology that was generally geared towards decreasing it. And once implemented, they actually saved the government over $1 trillion of money that would have otherwise gone out to the public. And Argentina is a very special case that we will talk a little bit more in the later slides, but they basically openly admitted to modifying, distorting the CPI for that period of time. And this is a period of time where inflation was so high that people clearly knew that the government was lying. Eventually, they stopped producing it in 2015. And out of that, though, some economists from MIT did a lot of research to recreate that period of time for them. And I'm getting a lot of the methodology that we would like to implement to create an independent CPI from the research that they did. And just to put it into perspective how politicized this is, Turkey in 2022, that's not very long ago, they actually filed criminal charges against an independent group that was trying to recreate an independent CPI number. I want to repeat that. Criminal charges, not civil, criminal. So this is how scared governments are of oversight. But before I can talk about the challenges that we run into on recreating an independent CPI, I need to talk to you a little bit more about how it's actually created and go a little bit deep in it, because that's where the challenges lie. So I hope you guys had coffee, because it's going to be deep. So first of all, the government gathers, oh no, this is the wrong presentation. Anyway, so these are the wrong slides, by the way. Anyway, so the government gathers information from administrative data and 2 surveys, household surveys and business surveys. And from that, they create a universe that represents the population of items that we all consume. Right? So this is a lot of information, and this universe don't only contain prices, they contain quantity, so that way they can figure out the market share of all the categories that are of things that you spend money on. And then once they have this universe that hopefully has everybody represented in it, they can get a random sample from it. And this universe is so important, because that's how you come out with weights, how you're going to weight each category. So in general, people will spend about almost 45% of their money on housing, and then 15% on food and beverages. So how you spend your money matters a lot, but them knowing how you spend it allows them to get a proper weight, so that when they calculate the CPI, it actually represents how you spend your money and is representative of inflation. So after that, then they take this sample and then they start collecting some information, and they'll take into consideration non-response, either because of no contact, or maybe some people just refuse to provide data. And then eventually they also have a privacy agreement with anybody that provides them data. So they'll suppress themselves if necessary, if for some reason people can reverse engineer pricing of items within the cells. And then after they do that, they'll go back, reweight, and then they'll start collecting information. And then while they collect information, they'll be able to observe item non-response as well as attrition rate. And so item non-response is like people might stop reporting what they spend on something. And attrition rate is basically people just get tired of responding to the survey, and so over time they just start providing information. All of these they take into consideration the next time they get a sample of goods, and they just oversample because they know that they're going to eventually have so much attrition that the sales will become impossible to publish. And then finally, once they're ready to aggregate this information, they collect it, they run it through outlier detection, they have analysts go through it just in case any stragglers were left in there. Then that's it, and they do some imputation for things that are not reported, And then finally, they do the aggregation, which is the easiest part of it all. Also, all of this methodology is very, very transparent. What's not transparent, it's the administrative data and the universe that they use, and then the micro data that is used for creating the actual number. There are 3 different CPIs that are published every month. The main one is the CPI-U. And even though it has had tweaks in methodology, it is very difficult to do tweaks in methodology on it because it's so politicized. Generally, administrations don't want to change anything, so they just don't. And that's the reason the change CPI-U exists, is because they couldn't change that because politicians didn't allow it. So they just created a different measure that had improvements in methodology. But in general, everybody pays attention to the CPI-U. All of this data is actually collected for free. Nobody gets paid. It's all voluntary data, except for the administrative data that the government requires businesses to provide. And so that's how that works. And guys, I really hate that I don't have my slides. So I talked about all the challenges within the statistical challenges of getting a proper sample base and making sure that you have those weights properly allocated, because that is what drives whether or not the CPI is going to be correct. The big criticisms of the CPI, however, are generally substitution bias, lagged inclusion of items, poor quality adjustments. So basically, for substitution bias, it's basically the government assumes that you are just as well off if you're eating a steak or if you're eating McDonald's. If you get 20 grams of protein a day, they're like, well, you're just as well off. They also, another criticism is that, and that's what they want. So they're always trying to make sure that that substitution bias that doesn't creep in, and it's generally an adjustment in methodology that leads the CPI to usually be lower. Rarely, actually, I've never seen any adjustments done for it to actually be higher. Lagged inclusion of items, if you choose a basket of goods at the beginning of the period, over time people change preferences or new items come into play. People, just preferences or new things. And so that becomes, because you start at a period of time, they don't continuously update that. So until the period ends and then they get another sample, then the old stuff is going to be there for a while. Poor quality adjustments is basically they're collecting data for an iPhone 12 and then next year is the 13. They have to account for the change in the technology because otherwise it's not just an inflation change but actually a technology change. The camera might be better. So those type of adjustments need to be done. Weights lag stem from the fact that there's a lack of inclusion of new items, and those preferences can change. And so the weights in the sample, the weights in the categories can change, but that's not really taken into consideration through the period of time because they're locked in. Now, all of these are not going to go away because we create an independent, all of these criticisms and things are not going to go away because we create an independent CPI. With an independent CPI, what we are trying to address is actually the conflict of interest, right? So if the government benefits from the CPI being suppressed, and they continue to make methodology changes to suppress it, because either they want an IMF loan or because it just saves them money, nobody really talks about the huge conflict of interest that exists right there. And everybody just trusts the numbers blindly. Not so much in Argentina anymore, but it does happen. So the conflict of interest, the censorship, suppression, and distortion is what we're trying to address. And what I'm proposing, and anyway, some of the challenges, so what I'm proposing is basically recreating this. Aside from the challenges that I already spoke about that every survey has, the biggest challenge to recreating a decentralized CPI is the fact that we don't have that universe data. And it is very difficult to reconstruct because we cannot compel people to give us their information, especially businesses, for free, right? So there's a couple of things that we can do to address that. We can, for one, we can buy the data, but going back to the fact that this would be a decentralized CPI, we cannot really implement too many incentives because we want to avoid self-selection bias. So if I actually offer to pay people money for them to provide information, and this is one of the reasons the government does not pay individuals to provide information, it's voluntary and free. It's because you don't want just poor people or people that need the money to provide the information, because then you're not getting a full representative sample of the population. You can infer from that. So that's a difficulty that we would have to deal with, but that's a difficulty that everybody deals with, including the government. Then, if we do it independently and in the decentralized ways, we would have the cost of decentralized storage, right? And then, if it's a public good, who pays for it? That's a huge question. And there are ways that you can incentivize the mechanism as a DAO or like as a community, especially if you don't trust your government. But it is a challenge. It is not something that's going to be easily attainable. And then getting an actual universe to have a proper sample, there's a couple of ways that you can do it if you actually have enough money and pay for it. There is Visa and MasterCard actually have a more robust universe of how we spend our money. But there are privacy laws, so they can't just go about telling people what you spend your money on, but they do sell aggregated reports on it. And those aggregated reports are probably much, much better than what the government has, but they also guard them very closely because that gives them, it's a source of income for them. So it's expensive. The other source that we could use is, there's these two other companies that collect scanner data directly from reporters, and they have agreements, exclusive agreements, by the way. So neither of them have everybody. So if you're providing the data to one of them, you're not going to be with the other. So and the value that these businesses get from them is that they get analytics back. And so, but their data is also very expensive. Now, another thing that it's for future research, and I think it's becoming more and more feasible, is actually allowing people to voluntarily provide their data with privacy-preserving mechanisms like secret proof, that you could potentially be willing to provide your information if it was protected, right? And we could just use your numbers to actually do either weights or reproduce the CPI. And then the last thing, I really wish, and the last thing, because I think I'm getting kicked out of the stage, that I want to talk about is what we can do currently. So currently, there is no weights, there is no fix to the weights problem, and we've seen that even with the recreation of the Argentina. So from the research that was done through Argentina, price stats came about, and it's a product that provides different CPI numbers for different countries, and they still apply weights from the government. So the weights problem is a very difficult problem to solve unless you have enough money to get all of this data from private companies or create a shadow survey from people and just ask anybody that that is being surveyed by the government to provide the data also on chain, and then now we have the macro data to actually validate it. But then again, that comes with like a lot more research on how CK proofs can be used for that. I want to close with a sentence that was probably earlier. Sorry. Why this matters is because Benjamin Franklin once said, "But in this world, nothing can be said to be certain except death and taxes." I went ahead and corrected that because in the US, if you have enough money, you can probably avoid taxes. But no matter who you are, you you will experience inflation, no matter who you are, how poor you are. It doesn't, unlike governments, it does not discriminate. And with that, thank you so much for your time and for staying behind. Sorry.
Thank you, Brenda. Danke, Brenda. Gracias. We don't have time for questions, but thank you so much for the panel, for the presentation.
Thank you.
Coming out from Brenda's and the development of a new macro on-chain data, I can tell you, like in Argentina, where I'm from, this is clearly what happened, and today people don't trust it anymore. Even when they have to rebuild it again, it's difficult for people to start believing in something that they lost completely trust. Today, we have several indexes that we follow, and mostly the average Argentine will have in their mind what's the inflation rate of the last month, and what's the difference between the national inflation rate and the local city inflation rate. And this is kind of like what Brenda was saying, that it's more of a trauma that we have, and I think like with solutions like this, hopefully they could be rebuilt, the trust. So next up is Gisli Kristjansson. He's the CEO of Monerium. They're issuers of the stablecoin URE and also GBPE, and he will be speaking today about the challenges that they face as a stablecoin issuer, and as well, and how they are overcoming the liquidity and distribution topics. Welcome, Gisli. Everybody can welcome him with an applause.
Hi, everyone. So, Monerium has been issuing stablecoins for 7 years now. And we've learned a thing or two along the way, which I'm going to share with you here. I just want to caveat this with being a regulated stablecoin issuer, we do a lot of things off-chain. You know, whether it's managing the reserves, reconciling them against the issuance, or just onboarding users. But our true North Star has always been DeFi. And we love kind of some of the properties, the atomic nature of transactions. And I really do believe, and I'm of the opinion, that these properties have some real value in innovation that can't be used in TradFi. So with this kind of intro, let's just dive into the talk of solving the liquidity problem of a euro stablecoin. So in order for this conversation to be meaningful, I think it's important that we try to understand the stablecoin market structure. So it's fair to say that stablecoins have reached a payment network scale. Last year's transactional volume was $30 trillion. And we now see the TVL of stablecoins, or the supply, above 300 billion, up from around 30 billion 2020. And last November, Treasury Secretary Scott Bessent predicted that we'll reach 3 trillion by the end of 2030. And actually, most of the leading financial institutions reached the same 2 to 4 trillion range within the same time range. The euro represents roughly 0.35% of the stablecoin market, which by definition means there's not a lot of liquidity in that market, and that affects the slippage and the price of swaps. On the US side, we also have mostly two issuers that are accountable for most of the TVL. On the European continent, we see a completely different story. The liquidity is scattered among 20-odd issuers, creating liquidity silos for an already scarce liquidity. So we see the rails work, but the structure doesn't. And if we now zone in from sort of the high level down to some of the key challenges any stablecoin issuer is facing, let me walk you through 3 of them. Number 1, distribution, meaning how do users get their hands on the stablecoin in exchange for fiat currency? The US dollar-denominated stablecoins are mostly minted and redeemed through centralized exchanges, on and off ramps, and other centralized intermediaries. For the euro, that has been a challenge because those exchanges haven't been incentivized to bring it on, because many of the exchanges don't even have a euro-denominated trading pair, right? And then number two, liquidity. So liquidity is how you trade and trade in and out at scale, or how efficiently you're able to do it, and connect into the wider ecosystem of assets. And we usually measure this efficiency by the slippage or the spread on the asset. And here again, non-US dollar stablecoin issuers have faced some challenge, because many of the exchanges, again, haven't had any euro-denominated pair, and even the European exchanges, they have more volume in the dollar pairs for Bitcoin or ETH. So it's kind of a struggle for non-US dollar issuers. And this again affects the pricing of stablecoins. Then thirdly, it's the use cases. So for any stablecoin to be valuable, it needs to kind of break out of the crypto-only speculation. And for US dollars, they have had a very valuable use case for people around the world living in countries with weak currencies. So just holding onto a dollar has been one of the use cases. Unfortunately, for a euro or a non-dollar stablecoin, we haven't had the same privilege, so that hasn't been a use case, even though the political changes we're seeing right now may actually be changing the wind in our direction. So stablecoins are mostly traded on two kinds of venues. It's the centralized exchanges and the decentralized exchanges, and each comes with their own pros and cons. So let's walk through the centralized exchanges. We can issue our token and list it on an exchange. Usually the exchanges will require a listing fee that ranges anywhere from 100,000 to 500,000 per exchange. In order to support the launch on an exchange, a certain base liquidity is required, or else the token risks getting delisted. So this is generally where market makers come into the equation that are placing both buy and sell orders on behalf of the issuer, so that the users on the exchange are able to use the product. The market makers themselves will generally demand monthly retainer fees, and they will demand an inventory of the token to place the orders. And if issuing a stablecoin is a bit different than any DeFi token, where the team behind the token may hold a portion of the token from the initial allocation in their treasury and can use those tokens in order to provide this liquidity. For a stablecoin, that's much harder, because as we know, it needs to be backed fully by a euro in the bank in order to issue the tokens. Now, for DeFi, that's a different story. You are generally not required to pay any listing fees. Anyone can deploy and seed the pool with an asset and a stablecoin, and now you have a market. And the protocols themselves will generally share the fee revenue, the trading fees, with the liquidity providers in order to attract more liquidity for better pricing. However, as we've seen, usually those revenues aren't enough to attract the liquidity. So the issuers themselves are expected to incentivize liquidity, and the cost is roughly 100,000 euros per 1 million. And then you can take that and multiply that by the number of the pools that the token is traded in, and by the number of chains, and you get to a big number. So all of this exuberant cost makes it so that neither option is really viable. And even I would go as far as to say that the AMM model, which I love for the tail assets of DeFi, is not efficient for stablecoins that kind of mimic the FX market. So, as I mentioned, these DeFi and decentralized exchanges have certain properties that are advantageous. And one of them is that liquidity can be sourced from multiple pools. So you can have Uniswap and Balancer with the same tokens, and that can be aggregated into more liquidity and settled in one transaction. The other thing that is interesting is a user that wants to trade a token from token A to token C can actually do so by exchanging A for an intermediary token B, and then from B to C. And all of this is settled atomically in one single go. This would be the equivalent of you being able to buy Bitcoin on Kraken, selling it for dollars, let's say, and selling it on Binance for ETH, right? And all of this happening in one single settlement, which is obviously not possible in TradFi. So intent-based trading emerged as a solution to one of the quirks of DeFi, namely solving the user experience. So instead of the users interacting directly with the protocol itself, now you'd have a network of solvers racing against each other, finding the best routes and therefore the best prices, and then settling in one go, including the transaction fees for the blockchain itself. So this was a much better user experience. But crucially, the solvers themselves can use both the liquidity they see in the pools, but they can also source private liquidity. So when we were faced with this liquidity issue, we could take this in two directions. We could either raise funds in order to seed the pools, pay the market makers, pay the listing fees, and so on and so forth, or we could try to do something innovative and new. And we decided to try to understand, can we use the atomic nature that I mentioned in my intro to do something clever? And we started to ask ourselves, what if we don't, with the atomic nature of the blockchains, what if we don't just use it to exchange and swap two pre-minted assets, but we actually mint the euro on demand into the settlement? So this was a key insight that we saw, that we as the minter of the tokens, we hold a special privilege. And we have an unfair advantage over everybody else who wants to make liquidity for our tokens. So what we have essentially built is a trading facility, and we're market making our own tokens in a way where users can swap from USDC into euros, where we mint on demand. And again, this new liquidity primitive is, of course, composable, meaning that solvers will find paths from any token that has liquidity against USDC, and then now that token now has liquidity for euros. So how it works is we stream our liquidity to the solvers, who then use that liquidity to showcase that in the UI of the venues like CowSwap. When the user does the trade, they give their signature, the trade happens, we mint, and now we hold USDC. We sell off this USDC in exchange for euros that now back up the EURI that we just minted. So that is a real innovation in our minds. We are starting with Ethereum mainnet, and we will be launching on other chains as well. We are also going to be able to do this not just for the euro, but also for the GBP, the pound that we do, and any token that we wish that we will do in the future. And the cool thing here is we can actually reuse the same liquidity across all chains, because we don't need to pre-fund the trades and have it sit idle in one pool where it may not be utilized, where there's liquidity need in another pool. We can just stream the liquidity in all the pools, and wherever the trade happens, that's where we went. So I was here last year, kind of hinting at this capability, and this year I'm telling you that this is live. This is now, we support up to 100,000 euros and dollars in both directions. We will be taking that up. We can effectively do virtually unlimited amounts in the direction USDC to euros. And here we are seeing CowSwap on the left side, where the user will get 85,852 euros. And if we compare that with the best, let's say, retail product for TradFi, TransferWise, we're beating that by a small margin. So it's at least at par. The other cool thing is that the user on the left, he will get the settlement is happening in 15 seconds, whereas TransferWise can only guarantee delivery of the euros the day after. So here again, we are able to create liquidity for any token in your wallet that has liquidity with USDC. So if you are now building on top of Monerium, or if you're building, let's say, a neobank use case or a payment service, and you need conversion between all of those tokens, we've got you covered. So lastly, I just wanted to mention, I think we now start to see kind of the recipe for bringing the world's money supply on-chain. Number one, it needs to be regulated. I think that's become evident by now, and Monerium was the first regulated stablecoin to get a license in Europe back in 2019. Number two, you need access to local rails. Monerium was the first to connect the SEPA system to blockchains back in 2021, effectively connecting the 21 trillion euros in the SEPA system, which freely flows on-chain and back, and we support third-party payments in the name of the customer, in the account holder. Deep liquidity, that's what we've been talking about, liquidity on demand. This is a new, efficient primitive that is way more efficient than pre-funding all the trades. Global offering, so we've just expanded the scope of whom we can onboard. It used to be Europeans only. Now we support over 150 countries where we could onboard users. And lastly, I think it's important that this infrastructure is all composable, meaning that if you're building a neobank, you can share KYC data with us, open up an IBAN for your users, and therefore create a Revolut-like experience that is globally available from day one. So if you're either a user, please try it out. If you're building, help us bring the world's money supply on-chain. Thank you. I don't know if we have time for questions.
There's some time for questions. So if anybody has a question here for Gisli, please raise your hand and we'll be handing the microphone. There you have some.
You mentioned that you guys are expanding to GBP. Do you guys have any plans to go to other stable coins from different countries that you, with the license that you have, you can also operate?
Yeah, great question. So I think there are two angles here. Of course, I mean, with the license we hold, we can issue any stablecoin we want, right? So at some stage, I think that will be a reality. The only issue remains, if we take a look at the first slide here, where we're kind of covering the market structure, it's evident that the dollar is still king, the euro is number two, and all the remaining currencies are less than the euro. Right? So I think it's very important that we focus on the adoption of the currencies today and make sure that the euro has a good standing, and then we'll branch out to other currencies. Any further questions?
Thank you. Thank you, Gisli.
Thank you.
Thanks. Okay, during these days here in Berlin, I was experiencing URE firsthand as a foreigner who can just travel and do the on-chain exchange in your self-custodial wallet into the local currency and be able to spend one-on-one. I think it's one of the greatest experiences for any traveler around. Hopefully this can be replicated with these lessons all over the world, and everybody has a global bank in their hand. At least that's the on-chain banking vision that I have. So next up is Joseph Jelacic. Sorry, I knew I was saying it wrong. Joseph, he is from OWN, and he's been building DeFi mortgages for a while, and I think today he has a pretty good news for everybody, especially for me, because I'm in the moment of trying to buy a house and enter there in the market, and I'm sure I can't do it with normal fiat, but maybe in crypto, having a mortgage will help me. So thank you very much. Joseph, welcome. Joseph, with a round of applause.
Amazing, thank you. I'm also excited to, in a long time, to speak about something that's real and tangible and that actually happened, not just about theory. My name is Joseph. I've been around for quite a bit. Does anyone remember Pawn as a project? Awesome, a few people. So long story short is that I've been through this journey of growing up, and so was Pawn, and it was our initial project that enabled universal peer-to-peer lending in an intent-based fashion, where we started experimenting with all sorts of different loans. But the reason for why Pawn has started was the fact that I was in a similar situation as the gentleman before me, and I had an issue to get a mortgage from traditional finance because I was too entrenched in crypto. And Pawn was started as this potential solution or pathway to a solution, and finally, end of last year, we kind of graduated from Pawn to OWN to start focusing on one of the painful parts of being in crypto, which is getting access to something else than crypto, something real, something tangible, which in our case was real estate. So my story is that no bank would touch me. I tried to get a mortgage, I failed several times just because of my affiliation. And this is a story of what we created to actually fight that. So is anyone familiar with Bordel? Less people than Pawn. But Bordel is a hackerspace. Last year, I would say, was a hackerspace, but now it's a soon-to-be hackerspace again. Founded in 2020, essentially during COVID, in the basement of Paralelnipolis. Some of you might have seen this tweet. I think it was from Bankless. That was around the merge. And the picture down here is actually the original Bordel basement with a bunch of guys from the Get team testing the merge. And it was our little sanctuary, that's a popular word, in Prague, where we just had fun. And we were hacking on a bunch of things and did some crazy experiments. But it was like a small community space where like-minded people could meet, just a traditional hacker space, right? The other part of the story is that around the same time, I faced these rejections from TradFi. So during ListConf in 2021, I talked about how to get a mortgage as a crypto native, talking about the ways you can achieve a similar type of exposure to a mortgage-like loan if you're a crypto native. And it took me a bit to actually build something tangible. So the story of Bordel actually ended in 2023 when we had to leave the space, and shortly after Paralelnipolis was closed. But in 2025, there was a new wave of enthusiasm, especially thanks to Mario essentially keeping the whole idea of Bordel alive during the time when we didn't have a physical space. So we started talking about opening up a new Bordel. We started talking about, okay, let's be crazy a bit. Let's actually put all of those ideas to work, and let's raise a DeFi mortgage. Let's try to buy a physical space that we can call our own somewhere in Prague. So we got down to work, started building prototypes, started playing around with a bunch of ideas, built a UI in early 2025, and it took us a bit to actually get things started and actually make the move. The target was that around DappCon in Buenos Aires, we're going to launch the very first DeFi mortgage. So how does a DeFi mortgage look like? Anyone here from TradFi? No. So usually the TradFi people hate me. I always say a DeFi mortgage, and they tell me like, how is this a mortgage if it's just on crypto and it doesn't, like, how does it touch real estate? The point here is, what we wanted to create was the most decentralized version of what we could. And it's obviously like hard to build something that's decentralized and connected to the real world, legally also. So we wanted to recreate a mortgage-like experience, mortgage-like exposure, mortgage-type functionality, with just using the tools that we could access in DeFi. So what we needed was a fixed rate, it's a guaranteed rate that doesn't wreck you in price swings, something that gives you long-lasting assurance, something that limits your risk, especially against getting liquidated, because that's a big pitfall. Like, you can take a DeFi loan, but then either does the thing that it just did last week, and boom, you're wrecked. Like, all of your plans are in a trash bin. We wanted something that there's no human factor either, someone that could rug you. And we also needed, for this to be actual DeFi, it had to be open. So it had to be composable with the rest of DeFi, and we didn't want to care about any permission setup or KYC as well. Our goal was to raise $250K for 5 years at 2.5% interest rate, which obviously is very low. So what you can get currently in the Eurozone is something between 3.8, 4.7%. So this obviously isn't a commercial rate here, but serves the purpose of the case study. So what we did was that we created and we leveraged the smart contracts that we built for our pawn previously, because they were made in a way where we could leverage them for this particular case. And there is the whole setup of smart contracts where we enabled crowdsourcing on both sides, crowdsourcing on the side of the borrowers and crowdsourcing on the side of the lenders. This is a pure DeFi mortgage, so it actually doesn't directly touch real estate, but it sets up the setup in a way where the lenders are protected and the borrowers can buy the real estate. That's what I mean by the means to an end. So first, we had to establish the terms, the LTV, the rates, and so on, and we created a crowdfunding vault, which essentially is a 4626 vault that you all know, and if you use DeFi, very likely use as well, where people could deposit USDC at this promised rate of 2.5%. Plus, if they contributed enough, they would get exposure to some perks from the physical space, like membership, like hosting your server, like being able to host an event at the hackerspace, etc. We didn't want them to incur any loss or opportunity cost during the crowdsourcing period, so this was open for 90 days, and the funds from the vault were proxy deployed to Aave to earn some baseline yield. So even during the waiting period, they weren't using against the variable rate of what DeFi provides. That's kind of the composability aspect. Then the second step is for the borrowers to actually put down a deposit. So it's not, the DeFi mortgage is not really about locking the house, but you can imagine using something like tokenized real estate as well instead of the wrap ETHFI ETH that we use here. But we set up a safe wallet where the contributors, the kind of founding members, have crowdsourced wrap ETHFI ETH as the collateral. And we locked it, and as soon as we collected enough money, we locked it as 75% LTV using the pawn protocol. So this is where we are at now. We essentially executed the loan. The collateral sits in the pawn protocol. It's wrap ETHFI ETH, so it still generates some yield on its own. And we triggered this loan, essentially pulling the money from Aave through the proxy vault into the Gnosis safe, or the safe wallet. Now we have essentially a stablecoin loan, which we can use to buy the particular property. Once the property is purchased, then the perks unlock for all of the lenders. In this particular case, we had over 47 lenders. We had actually 47 lenders to contribute to the Bordel case, and on the side of the borrowers, we have 6 people. So once the loan is executed, then there is a grace period of 6 months to get all of the paperwork done, and the fixed rate request is triggered. So after the 6 months, the borrowers have to start repaying the loan. So this loan won't get liquidated on a price dip, but it will get liquidated if you stop making repayments. And for the entire duration of the 5 years, if you miss one single repayment by like 1 cent, then the smart contract allows anyone to liquidate the entire collateral, which, I mean, in this case means that the entire collateral will be transferred to the proxy vault that was in the beginning, and therefore the lenders will get their own share on the collateral. So in order to fight this price uncertainty, the entire collateral remains at risk until the very last repayment. We didn't want to include an oracle because, well, we don't know if there will be any oracle function in 5 years. And we also didn't want to create this structure where you could lose everything in order to get that real estate, because it wouldn't actually serve the purpose of getting the mortgage. So then after repayments start flowing in, then the lenders can claim the yield, the perks, and boom, everybody's happy. So how did it go? On day 1, during the Ethereum Culture Day, during DappCon Act, we raised 80K in like one shot. It was, I don't know, like 4 or 5 people contributed, and boom, we were at 80K. For the next 2 months, not much happened. So we raised like 5K for the duration. We were trying to communicate. We were trying to build up the structure. We were slowly giving up on making this happen. Then day 70 came around, or roughly 70, and we found it. We actually found a place that we could afford with the money. We knew there were other places that we kind of looked at, but nothing was actually perfect. Like some places were kind of dirty, what would like require a lot of investments for the hackerspace to exist. But on the day 70, we found a perfect spot, which cost like 150K, was actually dry, 70 meters square, was perfect. And it kind of kickstarted the enthusiasm again. So within the next 14 days, we went hard and we started actually reaching out to everybody that we knew. And boom, actually 12 hours before the expiration of the loan, we raised it. We raised 180K, which was the minimum from the 250 that was the target goal. And that money still enabled us to actually execute this entire thing. And again, it wouldn't be possible without the 47 people who contributed as lenders. And a lot of people actually got excited in the last days, which kind of made it actually made the process fun rather than being super stressful. And like the worst case scenario, like everybody would just get their money back, right? So what did we find? We're getting a bunker. We're getting a 70 meter square bunker in Prague. It has everything that you can dream of, right? There is a decontamination shower. There's a massive ventilation system in case of like a chemical attack. There's a proper bunker door, and an escape hatch. Like everybody needs an escape hatch, right? In this environment, in this economy. So we're now in the process of setting up the paperwork. A lot of that has actually already happened. The important part here is, coming back. The important part here is the legal structure was kind of completely invented out of nowhere. So this works in particular in Czech Republic. I think the similar structure could actually work anywhere across Europe. But what we did is that we established a stocks company, and then people who contributed to the collateral formation received shares in that stocks company based on their contribution. The whole point here is that we had a bunch of crypto natives who wanted to crowdsource money to co-share, co-own a hackerspace, but none of them wanted to just sell their crypto and lose exposure to crypto, which was kind of the initial motivation. So this way, we simply create a structure that enables them to co-own the space. but if they comply with the terms of the loan, also to keep their crypto. So the incentive for them is to make sure the place works, generates some revenue, and actually is able to repay the loan, because the loan stores their private ETH that they would otherwise lose. So although there is no direct legal connection between the loan and the property and the stocks company, there is a very strong incentive for the stocks company being owned by the people who have a personal stake in the DeFi loan. Funny thing happened, and nobody actually assumed something like this would be possible. But that's kind of the magic we live in. We promise a rate of 2.5%, but what the lenders are actually getting is 5%. And the reason being that somebody made a mistake. So the way the proxy vault, the lender vault works is that you use the deposit function, which kind of drains the USDC that you approve, and then it mints you the shares, the lender shares in the vault, which is kind of the representation of your share on the repayment and the principal. But the very last person that enabled the loan, instead of using the deposit function, they just went and did the classic crypto mistake, and they just transferred USDC to the contract address, which means that they effectively donated the money to the lenders. The way the contracts work still enable us to execute a loan, which is fine. So we just basically borrow the full 180K. But this particular person won't be getting their shares back or their repayments back. So even though we didn't promise the 5%, we actually made it quite competitive mortgage from perspective of long-lasting yield income, which is very competitive to you investing in real mortgages in Europe. So what's the current status? As I said, we are almost done with the paperwork. We're missing one last signature on the shares takeover in the stocks company. We also, because it's still an active bunker, we just passed some of, and this is actually before it happened. So by now, the revisions for the ventilation system, for electricity and so on, they're all done. So that's kind of the legal side of the paperwork that needs to happen with the physical space. And tomorrow, we're getting the last signature on the paper, and then next week, we should be actually able to finally sign the purchase contracts and hopefully move in next month. And that's the case that we started. What we want to do as OWN is to fund more community spaces. So if you have an idea, if you have a project, please come talk to us. We want to help more communities to own their physical environments. So if you're building a hackerspace, if you're building a co-working space or a communal living project anywhere in the world, we want to be part of it. And we want to help you to not only use the stack that we created. By the way, everything that we use for the Bordel loan is public and open source. So you don't even need us to make it happen. You can just go there. There's no fee that you have to pay. You can go there, you can make the loan, you can fork the repo with the front end, and you can run with that. But if you want to do something cool, come talk to us, and we want to help you do that for free. We will even help you find the lenders just to make sure that we can prove that these systems can work anywhere in the world, and that you don't actually need to default to TradFi to do something in the physical world, something that's tangible. And I believe we have 30 seconds for questions.
Thank you very much. In fact, I'm going to scan the QR code. We have a few minutes for questions. I'll use the minutes to scan the QR code because I always have an ice cream type of space always thought for builders. It has to be ice cream, though.
That's awesome. I'm down.
Great. Does anybody has a question here for Joseph? We have a few minutes, so you don't have to think it completely in a rush.
Hey, Joseph. What about providing loans with other coins as collateral, such as Bitcoin, which some people may hold with a long-term perspective. And what about also kind of getting the cash in the bank? But presumably in this instance, there's USDC, and then it's kind of, for you, the home purchaser, to find your way to get that into cash.
So, so question number one is Bitcoin. I mean, this is all EVM contracts, so we can do wrap Bitcoin, T Bitcoin, and like essentially the wrapped versions of that on EVM. We're not like particularly interested in writing Bitcoin script and like porting this directly to Bitcoin. Also because the way it's written now, it enables, I guess, like the less decentralized versions, but the more commercially ready versions for doing this with something like tokenized real estate, where it kind of becomes like even more mortgage-like or even more tangible for a lot of people who are outside of the space. And the second question, the way we did it now was that we essentially just went through a traditional exchange, and I think we ended up paying something like I don't know, a few $100 in terms of the fees for turning this into fiat. So the purchase itself actually happens in fiat. I mean, it obviously was not a huge amount. It was like 150K roughly. So we passed all the checks. Nobody was hiding here at the time of setting up the company. It's like physical people building a company, transferring capital to the company, which is all normal. So we actually didn't hit any road blockers on turning USDC into fiat.
Okay, thank you very much, Joseph. It's we had the time only for one question.
Awesome.
Thanks
Thank
a
you
lot.
so much.
I was actually thanks. Yeah, like these spaces in at least in Buenos Aires, in Argentina, are coming more and more often. The builder community there always try to find a space for more like in-person meetings, and there's a few like Ethereum hubs happening, but it always end up being or too far or too expensive to participate. So these kind of initiatives, I think it sounds very appealing, at least for us at the emerging markets. Next up is Dr. Jan-Philippe Fritsche. He is from Bermuda Bay, and he'll be talking a bit about the myths that we used to have on giving financial institutions blockchains in order to do their operations. It's always been a hurdle between privacy of the financial institutions and clarity and transparency from regulators. So I think he's going to share a few good insights. I hope everybody likes it. Let's welcome Jan with a round of applause.
Yeah, thank you very much. Thanks for being here. So Bermuda is built with this belief that, like, as a user, you want to use your MetaMask wallet and Uniswap, but privately. But also, you want to, maybe as an institution, use Fireblocks, Safe, or any of the other institutional wallets and deposit into Morpho, but also privately, right? And as a developer, you might want to add privacy to your protocol application and without going to jail. So we have been building privacy tools for ages. So the problem is that with every transaction that is broadcasted to a blockchain, counterparties, amounts, asset types, and also the DeFi execution is fully exposed. And there are tools out there that can basically reverse engineer your balance sheet if you're a frequent user of a blockchain application. And the thing that we do at Bermuda is like we allow for privacy while also enabling risk screening. So why is that? The answer is here. Privacy tools in the past have basically been built without issuers and institutions in mind. And institutions are ready to enforce, and also to enforce with tools that are inconvenient, and basically freeze everybody. So this is a perfect example. Circle froze the whole Zama USDC contract, and that affected also basically legal funds and legal users because they didn't have an option to enforce their policies that they can enforce on the public set in the private set. So privacy tools in the past have been built in a way that they take away the capabilities that the issuer has. We took a different approach. With us, before every transaction, regulator or issuer-specific checks can be run. Identity-specific policy is also supported. Those can be implemented via self-onboarding with the issuer. On top of that, we have like baseline risk screening to avoid any kind of OFAC or sanctioned addresses. But really the main point here is that the issuer can select a set of tools that they need and they are used to enforce their policies on chain. So why is that so important? Well, for example, there's CASPs and WASPs and other service providers out there that might link back to the fiat system. And that also means that if you want to off-ramp, the off-ramping institution basically has to know where these funds come from. That is like international regulation, right? And this might be very, very complex and national policy that you have to implement. And we allow for that with like zero-knowledge analytics, and that way it's possible to do also private off-ramping. So how does that work, right? So Bermuda is basically a set of smart contracts, and these smart contracts live on any kind of blockchain. So you can deploy them on EVM mainnet, but also you can deploy them on your private chain as a bank. If you run a Hyperledger Besu chain, they could live there. And then these smart contracts do zero-knowledge proofs to basically allow the issuer to enforce their policy. So the outside world doesn't even need to know what exactly happens. It's all happening in the private. And one of our most important principles is that the issuer set the terms. We don't set the terms. Like Bermuda is permissionless. We can never look inside. Our operations shouldn't increase counterparty risk. That's the main benefit of a solution like ours. And then there's like a lot of other things that institutions need. So for example, at the moment we are working very hard on a quantum secure implementation, which is ready to be used. It's obviously a little bit more slow than the baseline solution. We enable account recovery. For example, many wallets, institutional wallets, like the Safe wallet, have a recovery option, also have blind signing protection. We can do private repo and a lot of things like OTC swaps in the private set. And I think this is really the main advantage. If you think of institutions and we want to enable institutions coming on chain, then they will bring on all different kinds of assets. So for example, a tokenized deposit from one bank or a real-world asset, such as a bond. And I think what we've also done as a mistake for a long time is like, we offer privacy for all these specific assets, but then we end up with totally fragmentation. You have your one wrapped asset and you have the other wrapped asset. And obviously those assets are then not very liquid and the assets are not interchangeable in the private set. So therefore we chose at Bermuda to have this omni-asset design, which basically has a policy registry in it, and then once you are within Bermuda, you exchange one asset against the other, or can also temporarily go out, interact with Aave, and come back in, all the policies are enforced. Yeah, and this is really a very, very important slide for me, because I think there's several solutions out there that attack privacy, but they don't get that basically the issuer always has to evaluate the counterparty risk. And like with solutions like Canton, you don't get a fully permissionless blockchain, but basically a server-based system. Then you have systems like Zama, where like you don't have issuer policies, and the whole Bermuda tech stack on top of the EVM is fully permissionless, and then the issuer and the recipient have control, but they only get the control that they already have with their permission token, and this self-onboarding is also permissionless, and you don't need to call us to get the permissions. You just need to ZK prove that you are the controller of the asset, and you get the permissions that you need. So the proving happens all on the client side. That means that your local device manufactures the proof, and then the verifier on chain checks if the proof is actually valid. This means also you don't have like infrastructure risk as you have in some FHE-based systems. Yeah, so this talk is all about institutional adoption, and I think there's one thing that really the industry has completely gotten wrong, and is like not listening to your users. And we have to acknowledge that now we are entering a time where institutions want to become our users. And institutions are basically embracing blockchain technology. And that means we need to listen to institutions, we need to listen to issuers, and also we need to listen to regulators. Because in the end, like the regulators might enforce things that we might not be happy with if we haven't listened to them in the first place. So this means we can build better tech, but we have to listen. Yeah, this is a pragmatic scheme of how like one transaction between two banks could work while using Bermuda. So you have your token, and then that token gets basically shielded within Bermuda, and then one bank wants to send it to another bank. This all happens in the private set, and nobody can see what's happening here. And while the transfer is being executed, several proof verifications happen. So for example, we can do signature verification, private sanction lists, public sanction lists, just as an example. And we are currently working with the Monetary Authority of Singapore, and will be presenting a solution next week at Point Zero Forum to basically see that in action. And yesterday, we had a really great announcement as well. So now we are collaborating with Linea and enable that thing basically cross-chain. So this means that you can go from one private chain to a public chain like Linea, and the transaction proof is also posted to a third chain, for example, Ethereum mainnet, to really verify that the transaction has happened. So you get privacy by Bermuda, interoperability by Linea, and then the full security by Ethereum. And like now I think we're moving to a world where we will see a whole range of new business models. For example, like tokenized deposits were like for a long time just a joke, right? Because like banks would tokenize a deposit and then it would sit on their local chain. So what can you do about it? Not a lot. But now, if you can create a virtual copy of that tokenized deposit on a public chain and then mint a stablecoin with that, you also get the possibility to basically instantly redeem a stablecoin 24/7. And that's a huge step forward, because with that, then you can go, for example, on another chain like Ethereum mainnet and deposit your stablecoin into a vault. And that basically that enables a full connection from the banking system to permissionless DeFi. And yeah, I believe that's really a breakthrough. If you want to try it, Bermuda is super easy to use. So you can basically try it today with no contract changes. You don't need to do anything on your side. We have an NPM package that you can use to engineer front end and do all the calls, but also you can just do the smart contract calls all on chain. And yeah, I'm here. Hit me up. Thanks for the opportunity to speak. Looking forward to your questions.
Thank you, Jan. Anybody has questions? We have, I think, time for 2 questions.
I have a question.
Yeah, we'll have the microphone so we can record this. Thank you.
So first of all, thank you. I'm totally new in the space, kind of lost, considered skeptical. Give me like a plain English that I can pass to my network, who is also skeptical, your product and overall what you want to achieve, like the easiest way. So I'm with Solana Super Team Island, did some project for Colosseum, help from the product UX, UI perspective. And what I'm facing as a newcomer is that the jargon push people away, especially females, newcomers. It's still like, ocean of unknown. So it's more like a thoughts than a question.
So my thought is, I totally agree with you, and I guess that's because, first of all, I'm a central banker, former central banker, so I speak banking terms, but also this is a very institutional use case. I think the non-institutional use case is just you have a credit card, you go, for example, with the Gnosis Pay card to the point of sale, you tap, you pay, and then the person that is sitting next to you saw that, they look up who just paid in that coffee shop, and they can exactly trace your balance of that payment card on chain. And they really can use any blockchain explorer to see all your activities, and we enable that it's possible that they cannot see that anymore. That's the plain English version. Is that the second question?
Yeah, for the time being, yes.
So yeah, this is the technical innovation there. So and that's something that we have to dig in collectively. Like the technology is called zero knowledge, and zero knowledge enables to verify that something has happened without actually showing the exact thing that has happened. And that's crazy. Like it's really hard to imagine that. It's a mathematical system where you can prove that something happened without showing the full detail of it. And I can't go into the mathematical details, but that's the keyword that you would need to look up to get your head around this.
Thank you, Jan. Sorry we don't have more time for questions, but actually I think it's pretty interesting that part because it's also stopping the industry to advance into the banking on chain. I think something cool that, at least from Gnosis Pay, in our next upgrade of smart contracts, there will be bundled payments, so it will be a bit harder to trace back to the wallet, but still to be fully private. There's a few protocols, and for sure these things of the part of the stack of the developer to include privacy compliantly in the blockchain.
Yeah, the good news is that we will be integrating into Gnosis app, so that's not, in the future, that's not longer a problem.
Okay, awesome. Thank you very much. Thank you everybody here for staying for today. This is the end of day 1 at DappCon. We'll be welcoming you back tomorrow. Starts at 9 a.m. So everybody is welcome to come back. There's going to be plenty of more calls and more projects to know. Thanks a lot. Have a nice afternoon.